Hello everyone and welcome back. So I'm Mayank Agarwal and today we are going to build an end-to-end project using Microsoft AutoGen, which is an awesome framework by Microsoft to build multi-agent system. We are going to start from complete scratch and I will also be explaining you each and every component for present in the AutoGen framework so that it is very easy to understand for anyone who don't have any idea about AutoGen as a framework, or let's say how we define agents and use them to solve a particular problem. The project which we are going to build is going to help us to solve DSA problems, and the same can also be used for lead code question, which not only provides you the solution but also explain that solution. And the best part is that any code which it will provide you, it will be ran inside a Docker container, thus making sure that the code is completely error free and ready to use. The same shall be very much helpful for someone preparing for FANG, or let's say if you're just understanding and giving coding interviews, as well as for showcasing your skill in the world of building multi-agent system, a skill which is, I guess, a lot required and sought after in today's world. As I said, everything will be from complete scratch, so the video is totally beginner friendly. And because all of you are so awesome, I will also be providing the code completely for free. So make sure that you check the comments and download the same. So now let's get started and see the same in action. So as you see right in front of you, everyone, AlgoGenie, our very own DSA problem solver. The same, as I said, can be used for lead code as well. Your personal DSA solver. Here you can ask solutions to various data structures and algorithm problems. So let us just first ask a very simple question. Write a function to add two numbers and let me do that. So I think we can allow that. So this overall permission was for using Docker, right? And in the backend, a Docker container will be running, which will make sure that our code ran inside the same. So let's see and wait for the overall result. Okay, let it wait. And yeah, seem like Docker has started. So the time was for Docker to just get started. And it is giving us the result, the whole plan as well. After that, we see that how it has done the same. So again, this was a very simple code, but yes, it is able to give us the answer. And finally, it is saying that code has been successfully saved into the solution.py and it is stopping. So we have a code executor agent and a DSA problem solver agent. So with this simple problem clear, let's now make it a little bit advanced and let me go to lead code, maybe just quickly refresh it. I can go to maybe one of the problem which I've solved. So let's go here and let me just copy this overall definition of problem and I can just quickly paste it. So let me just refresh it and I can paste it here and let me give the function definition as well. So it gives us the result in a similar manner. So yeah, we have a user are asking this particular question. Since the Docker is now started, it is not taking so much time. So let it think and give us the answer. So to solve this problem, we can use hash map or dictionary. Again, if you will see here, it is also explaining you the whole way or process of solving the problem. Then it will try to run this code in the Docker container. Since there is no print statement, it is saying that script ran but produced no output to console. So this time it will change the same and we can see that how the result is getting printed, right? And finally, it is saying that, okay, everything seems fine and I can save the same in a solution.py. But as R check, let me just copy this code and let me just use it to run on a lead code. So yeah, I think that shall be very much helpful. And let me run it. Okay, so yeah, seems like it is accepted. So good start. And I can submit the same as well. Okay, so yeah, beats 100%, 0 millisecond. Seems like our overall AlgoGenie or what we created using AutoGen is working pretty fine. As you can see, we have the full, very functional front end as well, something which I will also show you how to build. So with all that clear, make sure that you are completely ready with your system. Do make sure to see the complete video. If you have any doubts, ask in the comments and I will be more than happy to clear the same. One last thing before we start on to implementing the same. If you are interested in learning more about AutoGen, then please head out to this particular course. So if you go on Udemy, we have a course which explains AutoGen from complete scratch and more such awesome project end to end. You will see that how it has 4.7 ratings, 57 people have very nicely rated it. We have close to 1900 students. And if you use the coupon code June03, you shall be able to get it for the minimum price of 399 or I guess $9 depending on your country. So do check out the course as well, everyone. It is going pretty good and it has more than 34 hours of content, which will shortly be updated with more projects on RAG and MCP. So with that, now let's jump on to implementing our project end to end. And I'm pretty sure that you are going to have a great time in implementing this. Hey everyone, so let us now begin and start creating our project AlgoGenie in Microsoft AutoGen framework, in which, as we have seen, our agent or the team of agent is not only going us to provide the code for the given DSA problem, but also make sure that it runs the same. And if there is any error, it is able to solve and further make changes onto the code, just like any human would do. Now, I'm pretty sure such agent will be very much helpful in our DSA journey and for any coding related task as well. So let's get started. Now, as we can see, we are going to use AutoGen, which is a framework for building AI agents and application. We can go to its homepage as well, where we can see that it has multiple components. We have already covered about Studio in depth, which is a UI based application by AutoGen, in which we can create some basic agents and do prototyping. So the kind of agent we are going to create today, that is something not possible in Studio. So understanding the core AutoGen is also very, very important. Now, before we move forward, I would like to show you one thing that why it is very important to see this video from to complete end. Because many of us, what we might do is we can go to ChatGPT and just maybe paste that, hey, can you give a Python script in which we create agent using Microsoft AutoGen framework to solve a DSA problem, right? Maybe this thing can solve the whole thing for which I've created this long video. So let's click enter and see that what our LLM is given. So let it give the code and seems like it is giving us a very good code. And I can just stop this video because my young, all things are solved, right? Well, totally wrong. And the problem with this kind of uh, code and vibe coding in very latest topic is that this thing which we see here, that is totally wrong. Like the very first line in which it is importing AutoGen, right? This is the wrong way of using AutoGen as of now. So yeah, let us hold on and try to understand that how what exactly is the right way and go back to our code once. Now, everyone, what I have done to make sure that we are easily able to understand each and everything in this project, I have created a full flow which you are going to follow, and I have divided it into multiple steps. So let us try to understand these steps one by one. The very first one is going to be the AutoGen basics. So in a quick 7 to 10 minutes, I'm going to walk you through the most important components which are present in Microsoft AutoGen. The same I believe is very important because if you're a fresher or even if you have some experience with AutoGen, it will be very helpful as a refresher. Even if you're aware about these things, please see them as I guess you will learn a lot. Then we are going to see a quick example in which practically all the components which we have seen, we are going to just see that how they connect with one another. And yeah, in this, I'm going to tell you why that code given by ChatGPT was wrong. After that, we will try to understand the project and see that how exactly are we going to tackle the same. So we are going to create an HLD diagram in which we will see that, okay, what exactly based on our understanding of AutoGen components, we are going to create and further then use them and how exactly are they going to interact. After that, we are going to code and test our AutoGen team. So team is just a multiple agents because we are going to create multiple agents and make this a little complex project. And once we have done the whole backend part where it will work in our terminal, then we are going to move and create an interactive front end as well. Now, in that front end, we will be able to see the code in a lot better way. And of course, we are able to also see if any errors are coming. And that would be an application which you can even showcase to anyone. Now, once we are done with the logic of the backend and the front end, then we are going to make sure that we move on next to making a proper end to end project structure because I don't want that the project which you're doing with me that is just having two files or it is just running without any structure. Whenever we are creating any project, I totally believe that along with software development practices, we should make sure that it is properly end to end so that if required, we can deploy it anywhere else as well. And of course, then we are going to test out the application and do a party because this is going to be a very big project and surely we are going to master a lot of things. So with that, now let's move on to the very first topic, everyone. That is going to be our AutoGen basics. And let's see that in action. So yeah, AutoGen basics. Now you can see multiple symbols here. These are basically all the components which are there present in AutoGen. Now, before I move on and explain you about multiple other things, let's first understand that why from AutoGen. So, 1 second, yeah, Mm, just a second. Great. So, from AutoGen import, which was given by ChatGPT, why exactly is that wrong? Because I told you that that is going to be totally wrong thing, and we should not be learning that. Anyone, if it is he is coding with this thing in AutoGen, please don't see that, because that has been totally been that is actually not AutoGen by Microsoft now. So let me just tell you a little bit of the history quickly, everyone. So what we see here, that this is the AutoGen which we are going to use. This particular AutoGen with version latest being 0.6.1. Now, seeking technically anything above zero point 0.4 is totally fine. Now, the reason for that is before zero point 0.4 version, Microsoft was running on zero point 0.2 version, as we can see here. So there is no zero point 0.3 version. Okay. And it got split up into a framework known as AG2. So maybe I can copy this and explain you better. So earlier, AG2, this framework, was what was known as AutoGen only. But maybe due to some team differences or whatever reason, it actually got split up so that we got a AutoGen, which is now handled by Microsoft, the one in which we are going to do our project. And this is the AutoGen, which is a totally separate framework. Now, if I go and show you, that is the code actually. So we can see from AutoGen import, assistant agent, all these agents. But that is totally wrong. This is not anymore by Microsoft. So it is very important that we learn about these things. Okay. So with that quick lesson, let me close this. And that is very important because I don't want that you copy the wrong code or any LLM provides you the wrong code. Because even these uh, Copilot, they are also not very updated with these new frameworks, right? So now let's try to understand the basics, everyone. Let me show you this particular diagram, and we are going to understand each and everything inside them. So let's start. Now, coming to Microsoft AutoGen, there are, I believe, five major components which we have to understand. They are agents, tools, model, team, and terminate condition. So if you see here, these are the one which I have also drawn. So this is our agent in a way. Then after our agent, this is something which is known as tool. So this is tool. Then we have overall brain, or I like to call model. After that, we have the team, and then we can have the termination condition. So if you are aware about these quick things, surely you will be able to code a very good solution in AutoGen for any problem. Now let's try to understand them one by one. Agent, as the name suggests, that is just an artificial human. So just like we are human being, agent or AI agent is a artificial human being. Like that is the easiest way to understand that. And agent, normally we can have multiple types of agent in AutoGen. So we are going to have an assistant agent, which, as the name suggests, is going to assist us in multiple things. Now that is having an access to LLM in a very easy to understand manner. You can just think of chat gpt. So this chat gpt also has an assistant agent. So you ask it a question with the knowledge which it has of LLM, which is, let's say, GPT-4o model, and multiple tools which it has, it is going to answer your question. So just that is the understanding. This is a pre-built agent which is given by AutoGen to us, and I can show you that as well. So let's go to the official documentation. And in this, we can see that yes, there are multiple different kinds of agent. Assistant agent being the very common one. Along with that, it also provides us multiple other kinds of agent as well. Another one being, which is going to be of our use, user proxy agent. Now, as the name suggests, user proxy agent means that it is going to be a proxy for the user. So wherever we feel that, okay, we need human in the loop, I hope you are aware about that concept, or wherever we need human input, right? A actual human input, a user input, that is where user proxy agent is going to come. because it is a proxy for the user. Along with that, we have another one which we are going to use here, that is a code executor agent, which executes our code as the name suggests. And of course, we have the base agent class from which we can create multiple agents, and other agents are also present, which Microsoft is further enhancing with latest versions. Now, coming to our agent, everyone, it has few properties, just like we as human have some properties. They are name, then they are going to be description, then next one is model. So coming to model, just like we have a brain, just think about your model as a brain. For AI, like just like we have a human intelligence, this agent, this artificial human being, is going to have a artificial intelligence. So in this model, we can give any GPT model, any let's say Gemini model, any Grok locally hosted LLM. So that is totally on us, but that is all what is supported. And if I go on the documentation again and go to agent chat, then in the models, we can see that how OpenAI, Azure, all these are the one which are supported. So Olama, Gemini, and with the upcoming versions, new one are also getting added. And the good thing is that since chat completion API, this OpenAI chat completion client is there, all the models which are in line with this are supported into our overall AutoGen. So with that, everyone, now let's move on to the next component. Next is going to be the system message, which is more or less the instruction which we pass to our chat GPT or any LLM. So let's say you are a helpful assistant who answer question which user ask in a polite manner. So these are more or less going to be the system message. And then we have the tool. So tools are optional. Now, just like we human, we have a tool like let's say we have a calculator, we have phones. Then in phones we have different apps. In a similar way, we can provide our agent with tools. Now, these tools can be as easy as some custom function, or there are multiple inbuilt tools which are present in AutoGen which we can use. So that is what completes our agent, everyone. So just to quickly help you revise, agent is an artificial human being in AutoGen. There are multiple different kinds of agent already provided by AutoGen which we can use. Assistant agent, and these are the three major one which we actually will be using. After that, each agent, it has a name, it has a description, a model or a brain. Now again, that is dependent. If it is a user proxy agent, surely model will not be there because that is a proxy for us, right? We have our human brain. System message and tools which are optional, right? Now let's move forward and let's try to understand a little bit about team and termination condition. Now, team, as it suggests, everyone, it's multiple agents when they work together. So when the problem become a lot complex, then surely a single agent is not able to help us, right? And that is where the whole concept of team comes in, where each agent, it's a specialized agent which can handle the task. So the task of a one big task can be divided into multiple smaller tasks, and we can make sure that we can implement them by the expertise of each agent. So that is the whole idea of a team. Now, coming next to the termination condition, everyone, what happens in a team in AutoGen is that once the team starts working on a particular task, so let's say if I ask my team of three agents, where one is going to give me the logic, second one is going to run it, and third is going to check the code, whatever we have asked. So let's say I have asked it to write a simple code for add two numbers, right? Now, in that, when will we get to know that they have to stop, right? So we human also have some mechanism by which we understand that, hey, we have completed the task. Now we should stop. Maybe we raise our hand and say stop, okay, or it is done, something like that. So in a similar manner, there are termination conditions which are defined in AutoGen, which tells our team or which tells us that okay, the team has done the work, right? Now termination condition can be as easy as let's say all of them got a chance and we are just stopping maybe to see the progress, or let's say we can have some maximum number of turns. So maybe what we are saying is that okay, you take 20 minutes, or let's say you take 20 turns, right? First the problem will go to this one, then it will go to this agent, then this agent, and of course it can keep on going to multiple agents and it is going to then stop. Or just like we raise our hand and say that okay, it is done, If a agent feels, or if the team feels that yes, the work is done, they can raise their hand, or maybe they can just throw out done. And on the basis of that, we are going to stop. Now it's going to make a lot more sense when we see this in action. But this is an important concept, so it is very important to know. So yeah, I hope that till now we have understood about these concepts: agents, tools, model, team, and termination condition. Right? Now, moving forward, just a quick thing I would like to talk you about multiple types of team and which are going to be the most common one which we use, because that is also very important and a core part of AutoGen. Now, coming to team, everyone, there are majorly the two types of interaction in team, right? So I will just repeat it again. Uh, Team are multiple agents working together on a problem. Since they need to interact with one another, we have to define that how exactly can they interact. And there are two major kind of interaction. Of course, we can define our own as well. But for the use case of this project, and for even I would say 90, maybe 80% of the use cases, we shall be very good with these kind of predefined teams. The very first one is the round robin team, in which they take turns. So let's say if this is the first agent, first the problem will go to this agent, then this agent, then this agent, right? So just like it happens in a round robin manner, the order in which we provide our agent, in that order only they are going to work on that problem or the task, right? So just as an example, let's say if I ask my team in a round robin manner to code and give me the answer for how to add two numbers. Let's say this first one, it is our DSA expert who gives us the whole logic. Second one is our Python expert who from this logic gives us the code. And third one is going to be our Python runner who is going to run the code to make sure that it is right. If there are any problem, then they can of course be in a loop, so it can go keep on going in a loop and solve our problem, right? Now again, there can be multiple termination condition. Either they can stop if each of them have a turn, or we can say that okay, stop after 20 turns, after 18 turns. So all these things can be handled in a termination condition, and this is a very important part, right? After that, next one is our selector group chat, everyone. So as the name suggests, in selector group chat, we are going to have some logic, some undefined logic. And I've also created this example. Let's say these are our agent. One agent is very good in geography, another agent is very good in history, and another agent is very good in science. Now, when the problem comes for, let's say, history, it doesn't make sense that first it will go to geography person, then to history person. Or let's say if first one is science, then first it should go to science, then geography, and then finally to the history expert. So in the selector group chat, as the name suggests, selector, it is going to directly go to the history person based on the name and description. Much like how if someone asks us that, hey, where is that counter, or where is that, who can help me with this? We just send that person to directly the person who can help, right? Instead of making him go round and round. Okay. So with that, I guess we have covered the major components, everyone. That is, again, I'm going to repeat. And I know that they are going to be a lot, but I believe that this kind of idea is very important. I don't want that you just code out any logic and you don't understand what is it. So agents, tools, model, team, and termination, right? These are all the things which we have. Now, moving forward, I would just like to quickly help you revise that how exactly things happen. First, we have to focus on this agent, everyone. Now, coming to agent, each agent has a model and a tool. Of course, depending on the agent as well. But let's say if we talk about an assistant agent, it is going to have a model for sure, and it can have a tool if it requires one, right? Then multiple agents forms a team, which is this particular whole square. And coming to a team, it needs to have a termination condition. So termination condition needs to have, else the team will keep on running. So I will just quickly help you again. Agent, it needs to have a model and a tool if it requires one. Then when multiple agents connect, there is a requirement of termination condition so that we can tell when they are going to stop, right? And a team can also have a model. So when can team have a model? When it needs this mind. So in a selector group chat kind of a use case, the team is going to have a model. Okay. So yeah, I believe that was a very over the top and good overview of AutoGen. I know that again, this is pretty much in depth and covered most of the things. Just see it once again because there are many components, right? So these are the major one which will help you to write code. Now let's go back and we are majorly done with this part, which is the AutoGen basics. Let me just mark a right one here. So let's say we are done with AutoGen basics, everyone. Just one more thing if I would like to show you. So AutoGen, if I go on the overall architecture as well, everyone, this is the AutoGen architecture from the official GitHub page of AutoGen. In this, we can see that if we just focus on this framework, then let's just focus on this framework part. It follows a layer kind of an architecture, right? So it has the core layer, which has all the logic, all the base classes. And on top of that, it has the agent chat layer, right? Now, this is very important as well because these are the exact libraries which you are going to install when we try to make our project. Now, AutoGen itself suggests that since agent chat is the layer on top of core, it has these agents which are defined, and this is something which we have to use, right? So, majorly for all our cases, we will be using the agent AutoGen agent chat layer, in which we have the different agents defined. Whereas, whenever we need to go inside something which is very basic, we have to go to the code layer. Now, this is very different from other frameworks, and I believe that that is where the beauty of AutoGen lies. It is a lot production ready because it gives us lots of control, and mastering it is very complex, but in like very overall helpful as well because this follows very good software practices. And surely any company going forward will require you to have this level of understanding for any particular framework. Now, there are easy frameworks as well where there is no complexities, but then of course they are not going to be that much overall configurable as well because since AutoGen is giving you all this, since Microsoft has of course a lot big understanding that how exactly things happens in a matured software development environment, they have made sure to provide you this layer which makes it a lot more configurable, right? So let's now move forward, everyone, and let's go to code. So we are all now done with this AutoGen basics. I think this is more than enough for the understanding even in this project. Now let me help you to understand this a lot more better by showing you a quick example. So let's go and see this particular code which I have written. And the diagram which I have used, everyone, I have also added that for your reference so that you don't have to ever go back to any other thing to understand this thing, right? So let me show you this code, everyone. Now, coming to code, first we see that there are multiple things which are not present. And don't worry, I'm going to show and explain you this code properly. So the very first thing, if we go on the AutoGen page, we see that we have to install this AutoGen agent chat, right? So pip install AutoGen agent chat. Now, if you remember, AutoGen is not something which we are using. So the plain AutoGen is not the library, right? So the very first thing which I would like to do here, I would like to create a requirements.txt. Then I would like to clear everything here and I would like to, so I am in agent chat. Let me just go back. Okay, 1 minute. So now I'm in the right directory, everyone. So this is the DSA solver. Okay, you can ignore this second. That should be fine. The very first thing which I'm going to do, which is a very good practice, and throughout this whole project, we are going to follow the best industry practices. We are going to do Python -m venv. I'm going to create a virtual environment, and I'm going to say that env. What was the name which we kept for our agent? AlgoGenie. Yeah. So env AlgoGenie, right? So let it create an environment and seems like it has created one. Yes, I would like to activate that. And we are going to select the Python interpreter as well. That is fine. So now we can see that. Let me just go source first, deactivate. So I think I'm in some other overall environment. Let me first deactivate that. Deactivate. And now let me clear everything. and do source env AlgoGenie bin, and then we can do activate. So now the environment which I have just created, that is getting activated. Okay. So let's go to the requirement.txt and try to fill up some of the libraries which we will need. So we are going to need AutoGen agent chat. This is one library we will shortly be needing. Then I'm going to write AutoGen hyphen core as well. So this is the next library. Now core of course is also required. It gets installed by default as well whenever we do try to install agent chat, because as I told you, agent chat is the upper layer, so it is having some dependencies on the core library. Now I can do autogen underscore ext, and this is again the third library which we will be using. After that, async IO is also very much needed, everyone. The reason for that is async IO is the library which is going to help us in asynchronous execution of our code. Now, AutoGen, it's totally based on the asynchronous event-based architecture. So if I go and show you, the version 0.4 start with the new event-driven asynchronous architecture for AutoGen. Okay, so let's go back, and you will also see here AutoGen 0.4 has been released. Like they are saying, we are not affiliated with any folks or startup. So that is the whole idea, that people don't get confused with AG2. Okay, or the previous plain AutoGen. Now with this, I can just have .env as well. And since I will be using OpenAI, let me have OpenAI. And yeah, I think these are all the libraries which I need, everyone. So let me now do pip install -r requirements. And it's going to quickly collect and install these libraries for me, along with so many of the dependencies. And we can just clear everything. So now if we go on the code, everyone, let us try to understand that. Let me close this. And let me create a .env file as well. So .env, where I'm going to keep my OpenAI API key. So we are going to use Open API key here. We are going to use the GPT-4o or 4o mini model. Now, totally on you. If you have some other key for Gemini, or let's say if you want to use the locally hosted model, you can surely use that as well. So I have pasted my key, everyone. Now, please don't try to use mine. Anyway, I will be deactivating it after the project. So if I just explain you quickly what exactly is happening here, all the things which we have learned, that is going to make a lot of sense. So let's try to understand them one by one. The very first thing which we see is that again we are importing async IO because we will be running our agents in a asynchronous manner. Then we are importing from agent chat our assistant agent. So this is our agent which I just explained you as a component. Then next we have the models.openai, right? So here we are going to use the OpenAI chat completion client, which again I guess is very, very important. After that, we have the AutoGen core tools. So we are just going to use a very basic function tool. So I can show you that what exactly is the tool as well. Then OS and .env. So these are the very basic thing, right? So that I can load easily my keys from the this .env file, right? So let's now move forward. What I'm going to do next, I'm just easily trying to load my key and of course read that. Once I have the key, then I'm creating my Open API client. So sorry, Open AI client with GPT-4o mini model. So this client is where you can specify all the things which you want. Temperature, what is the API key, which model you want to use. Once I have created my model, then this is where, so first focus on this particular thing. This is where I'm defining my agent. So it is going to be an assistant agent. It is having the model client as Open AI client. It is having a system message as you are helpful assistant that can reverse text using the reverse string tool, right? And this is the tool which I've given it, right? Now this tool, it's a simple tool which just reverse any text which is given to it. So it is in a way using the tool. We can of course use this agent as a simple LLM agent as well. And we have just provided this tool as a function tool. So just how we provide tool in AutoGen, and we have just provided our agent to use the tool. So if you now remember the thing which we understood about AutoGen, we have overall tool and AI model just plugged in into our agent. After that, I am just giving this reverse the text, hello, how are you? And I am just calling my agent.run with this task. So the task which I'm giving, it is just return, just reverse this particular thing. and it is going to reverse whatever is basically asked, right? So let us run this quickly. Let me just have the terminal Python, and we can say it is inside, I think, 0th folder, AutoGen basics, and we can run example.py. Okay, so no module name tick token. Let us install that as well. Maybe that is also getting used somewhere. So pip install tick token. Okay, so now let us run this. Maybe now it will work. Let me close this file and let us try to run this. Okay, so seems like agent has actually reversed the string, right? Agent easily is able to just reverse the string for us using this particular tool. Now I can show you that maybe if I just put out the result here without any change and now run this. Yeah, so now you will see a lot big overall thing. We don't need to be a lot worry about this. Just focus that how tool call request is made, right? And yeah, we will find many things here. How the function call was done. Tool call did the execution. This was the argument we passed, which is hello, how are you? And finally, we got the answer, which was the reverse string, which is this one. Okay, so again, don't get a lot wary or afraid of this response. This is not that difficult to understand. Just I wanted to show you that yes, actually tool is getting called. Okay, so this is all about running a single agent, everyone. And of course, that is going to be very helpful. Now, quickly, let us try to understand that how we can change it into a team. So as of now, we have just seen in a single agent way of running this, right? Now let's try to quickly change it into a team. So with the single agent run clear everyone, now let's see an example for the team as well. I've just created a simple file through which we can understand. Now for the timing, I will just quickly explain you what all we have imported. So if we will focus, just we have now a user proxy agent as well, which I told you is going to be a proxy for the user. So it's going to be a very simple team, right? Where we have two agents, one assistant agent and one user proxy agent. I have also imported the round robin group chat, the team which I told you about, in which we will be taking turns. So from assistant agent to the user proxy agent, it is going to go. And we have the text mention termination as well. So as the name suggests, it is text mention, right? Where if a particular text is mentioned, that is where we are going to stop the flow. So let's try to understand this as well. Now we are just easily loading our keys here as well. I hope you have understood that in the last code. After that, I first define my assistant agent, which is again a simple named assistant. Again, there are no overall uh, complex tools or something here. If I want, I can provide the description as well. So I can just maybe let's say provide a description that you are a helpful assistant that can write poetry. And here we have message, system message, you are a helpful assistant. Just a simple assistant agent without any complex tool. But it will require a model client that is for sure required. After that, we have a user proxy agent. As the name suggests, it is again a proxy agent that represents the user, which is us. Input function is going to be input. So the idea is that since we as user will be giving in some input, that input we are going to provide via the input function in Python. The same function through which we normally provide input into anything, to any value as well, right? Then text mention termination is approve. That means I'm going to stop the flow when I see this approve coming into my overall flow of the team, right? And then I've created a team here, everyone. The team is round robin group chat. It has two participants. First one being assistant, that is my agent. Second one being me, which is my user, right? After that, we have the termination condition as well, that is termination. And just I have defined the stream with the first task. So this will help us to see the messages one by one, right? So instead of running where I see everything all at once, via run.stream, we can see the messages one by one as they come, right? And using the console function. So this is also something which AutoGen provides in the UI, agent chat.ui. We can use to directly see the same as well. Now let me run this, and I think it will make a lot of sense when it runs. So I'm just asking that, hey, write a 4-line poem about the ocean. So Python team underscore example. Okay, I think I'm not in the right folder. Let me see. Okay, so cd 0 dot, and I can now do Python team underscore example. Let me make it a little bit bigger so that you can see it. See. So what happened here? Write a 4-line poem about the ocean. And then it gave me this poem, right? So in a way, if I just zoom in a little bit more, you can see that this was the very first task which again I as a user gave, right? After that, we see that assistant has given me the full message, which of course is going to be very helpful, or which like rather based on LLM, that is something which is the actual work it has done. Now, maybe what I can do is I can ask. So now it is waiting for my response. So you can see that how I, as a user, is a part of my team, right? Now I can have multiple agents and they can all just finally report to me. And since it is a since it is a round robin team, the flow will first go to assistant as it happened, then came to me, right? Once I answer and until it encounters approve, it is going to just move in this manner. So assistant user, right? So let me now move forward, everyone, and do one thing. Let me ask it that, hey, make it a little simple and about, say, Pacific Ocean. So real time, this is going to take in my input and give me the output. So let's see that. Okay, and see the Pacific stretches wide and free. So you can see that how it is so good in taking this output and overall how logical this whole flow is, right? So you have a AI or an AI agent, you can give it any system messages and it is going to answer you, and you can just as a user provide the input. Now I can say make it more easier to read with respect to language. Let's say I want that, and it has given it a little bit better approach, and I can now say okay, approve, and it's going to stop. Now we can see that how the same has been stopped because we encountered approved here. Okay. So in this again, there is an event which gets thrown up as a stop message, and we are able to just stop our whole flow. So with these two examples, everyone, I am pretty sure that everything which we covered in this full understanding of AutoGen, that is a lot clear. Now this is very very important since I cannot just start directly with the project where you don't have any idea about AutoGen. Okay. So let's now go back to our overall case. Let me zoom out a little bit and let us mark right here. I really do hope that with these examples, you are kind of all set with respect to your understanding of AutoGen, and you will not be doing from AutoGen import, and you know the libraries as well. So let's now move forward to the major chunk of our video, which is the project understanding, so that we can now finally start with doing the project based on what all we have learned from our AutoGen understanding. So let us now start with understanding our project in depth, everyone. Now the problem statement is right in front of us. It says that create a tool that uses multi-agent system with AutoGen to generate and run Python code for solving user-specified DSA problem like binary search or Fibonacci sequence calculation. So these are just two examples which surely we can try to run as well. But our idea is going to be that through proper prompting and able to make our agent run, we are able to use it directly. And of course, all the flow, which is that it is going to first generate the logic, then the code is going to get run inside a Docker container. All these things we are able to do by using the power of AutoGen agents. Now, if the problem is clear, this is what we are calling it, that is AlgoGenie. So for outside person, this is again not a multi-agent system or something. This actually is just a single tool. So that is why I have written a tool here, right? Let's see a little bit of idea that how exactly are we going to go about it, because I want to make sure that we are following a structure which makes your understanding a lot more clear on how to normally as well just approach any problem in agentic AI world. So let's see that, everyone. Now coming to AlgoGenie, the very first thing which we are going to do, we are going to have a task. Okay, so let me just write task here. So let me just say that we are going to have a task or a question here, which can surely easily provide us, let's say, which is actually the thing which our agent or which our overall tool has to do. Now, coming to this AlgoGenie, it will comprise of two agents. First agent is going to be our problem solver agent, which is having all the logic, which is having all the idea. And this is actually the smarter agent, which is going to just provide us with the code. The second code executor agent, it is going to use Docker on our machine. Now, the reason that we will be using Docker is that we don't want that it runs any code directly onto our system. And I personally don't also want that if I provide, let's say, delete all files as a input, and some code does actually get generated, it runs and delete everything. I want to make sure that it is confined inside a container. So that is the exact reason we will be using the best way of running code in our agents. And if you are also able to understand, this is a proper project, right? Where we are defining it in depth by using making our agent able to run inside Docker. So it's going to check the code or rather run the code. I think I should write run here. It's going to run the code. And depending on if there are any error, then our problem solver, it will going to go back to our problem solver. So we are going to something known as round robin logic here. It is going to go back here and like this, it is going to make sure that until and unless the code works, it is going to just make sure to make the changes. Then problem solver is basically going to say that yes, I it is done. Okay, so we are going to keep done as our termination word or text mention termination. Once the same is done, we can even generate a Python file. Although I would like to make sure that we are able to see the code instead of generating the Python file. Although, as I said, both things are easily doable. After that, once we have this whole flow working, then we are going to also structureize this code. As I told you, like structuring your code is very, very important. It is one way of writing a complete script, but surely that is not the way you are going to productionize your agent ever. So I want to make sure that you understand that thing. Once we structure it or add code structure, then we are going to use Streamlit to see a quick UI as well and able to, of course, easily run. Maybe we can do that before as well so that structuring is not going to be that difficult. But via Streamlit, we will easily be able to then, via the UI, see that how exactly our whole team or tool is working. And in real time, you will be able to see your code very nicely, what error it gave out, why it is not working, and then how the same is getting rectified. Okay. So yeah, this is going to be very much helpful, everyone. And once we add it into a structure as well here, then you can of course deploy it in on any web or any cloud application as well. That is going to be a lot easy, and you can just have some endpoint, etc. Okay. So let's now start. Let me zoom it in and let me have it here. Yeah. So the very first thing which I'm doing, everyone, I'm going to just create my agents flow here. So let me just write agent backend.py, or I can just say it as agent be works fine. That is how I follow the convention. Now, since we are already aware about things in AutoGen, what I'm going to do different rather this time is I'm going to use AutoGen agent chat dot agents import code executor agent. So the agent which I'm going to use, that is the code executor agent. Let me show you that on the official documentation as well. So if we go here and if I maybe search for code executor agent, okay, code executor, we can see this code executor agent, agent that generates and execute code snippets based on user instruction, right? So we are just going to use it as a runner. We are going to get the code generated to keep it separate, as I believe we can give better instruction to a separate agent. But first, I believe this is very important to understand. Now, of course, we can see multiple things here: the name, code executor, model client, all these things are there. But I think one major thing which we need to understand now, in the code executor, you can see that how we can provide Docker command line code executor as well. Now, what does that effectively mean is that I need to start, or rather I should start Docker in my machine, right? So let me just start it and let me see if it is started. Don't allow, I don't want to allow Docker to connect. And yes, seems like it has started. Okay, so in the backend now Docker is running, so that when my agent is going to work with any code, it will be able to create a Docker container. And I'm going to show you that as well, right? Now, one thing which we want to see here, yes. So this is the kind of code which I would first like to show you so that you have full idea that how exactly the thing is getting breakdown. And then we are going to make it complex as we move forward. So no worries of moving, like this is an example which I'm going to make easy for you. So let's get started, everyone. Now, the next thing which I wanted to do is I'm going to import some libraries, import async IO. Then from AutoGen underscore ext. So in the AutoGen extension, we have something known as this code executor. And inside this as well, I have this Docker. So I'm going to import this Docker command line executor, right? Now, since I'm doing this, let me close few of these things. And in my requirements, I will have to add a requirement which is going to be AutoGen ext, and it is going to be Docker. So this is Docker specific extension which I have to use. So that is the reason it is needed. Let me just copy this and also install that. So let me clear everything and do a pip install because our environment is not having this, right? So let me install this. Seems like it has installed that. So that should be fine. Let us go out and go back here, right? Now, since I have created this, everyone, we have the agent, we have the Docker command line execution as well. Let us try to see that how exactly now we are going to create our major things, right? So first I'm going to define my Docker command line execution. So Docker command line execution. As you can see, if I show you, it requires an image, which is by default the simple Python 3 Slim. Now you can actually just search it as well. It will just be having Python here. So if you want to have a complex project, you can maybe specify your own image, or you can just maybe give an image which is having other libraries as well, so that it doesn't need to install that, right? So simple Python 3 Slim image it is going to use. After that, it can also have again, there are many things which we can specify. That the major thing we are interested in, that is the work directory. So I'm going to specify a work directory here, which is going to be just temp. So this is a very common practice where we specify this temp directory, and I can just close this out. And by default, I'm using the Python 3 Slim only. That shall be fine. If I require, I can also give a timeout as well, maybe let's say of 120 seconds. And I think that shall be fine, right? After that, what I have to do, everyone, I have to define my code executor agent. So code executor agent. This, as the name suggests, it is going to execute the code, right? So I can give it a name. So, and one thing more, everyone, please don't fall for these auto completion. I think we have already seen this in so much depth that how AutoGen is not updated at all, because it is very new technology, very new framework. It is gaining a lot of, like, it is getting used a lot in the industry as well. And you have to understand this. Like, if you follow this, surely we are going to have a lots of problems here. So now let me do name, which is my code executor agent, right? After that, I can just specify the code executor here, which is my Docker. So I'm saying that, hey, execute this code in Docker command line executor, which I have given you. So in a way, we know that where we have to execute code, and we know that who is going to execute the code for us. After that, I'm going to copy this from here because I don't want to make any mistake in this. We are just giving a task. If you will see, we are just giving it a simple task. So let me copy this whole task the way we normally give to any particular agent as well again, right? So let me give this task. One thing which we will have to make sure in this is that it shall be indented properly. So I will just tell you, this is some code which we are giving, and the code is inside this Python, right? So we need to make sure that it is properly indented. That's the reason I have just easily copied that. Now, since this task is kind of a message which I'm going to send, so earlier also we have seen that how we connect in terms of message, right? We send a task, then it comes back to us. I'm going to import this message as well. So it is, I guess, in from AutoGen agent chat dot messages import text message. Yeah, I think this is where it is present. So now I have defined kind of a task for this, where the source again is me, that is user. And now I can just say, and please make sure that you follow this proper approach. We are going to first, uh, we are going to try, yeah, we are going to try things out here. So we are going to define a result. It is actually very much like how things are here, right? So we are going to just say result equals await code executor agent dot, I think it is execute only on message, right? So see, again, that is the reason I'm saying don't fall for this copilot. Even I have spent hours in fixing the issues which it unnecessarily add into my code here. So I have to just specify on underscore message, and I have to specify the task here. So I have to give my task, everyone, which is going to be inside this message. We can see, so message equals, I have just a single task. So let me give that in a list. That is how it expect is. See, sequence of base stat messages. And I have to also give a cancellation token, right? So cancellation token is just like when we ask any question to, let's say, ChatGPT, we see this button, right? So if I just, let's say, ask it, hi, and answer this. So this button is kind of the cancellation token. You can just think about this, right? And let me also import. So from AutoGen agent chat dot, okay, no cancellation is there as we can see. Let me quickly remember where it was, or we can search it quickly as well. So cancellation token. And again, I'm majorly referring to the documentation so that you understand. And I think reading documentation is very important. That is how I have mastered AutoGen as well. So recent changes as well. This is where all the things are going to happen. Okay. So let me now do AutoGen. It is not in agent chat. It is in core. We can see here. And inside this, we have the this cancellation token, which we can import. So if we see here, this is present in AutoGen core. Okay. So import cancellation token. And we have the cancellation token, which we can use into our overall system, right? Now, since I have told you that how AutoGen is a asynchronous, heavily asynchronous kind of a framework, I would like to have all of these things. I would like to have all of these things in a coroutine, right? So I will define async def main, and let me just add this. And now we will have to do lots of indenting, right? So let me indent everything here. But I still need to correct this because else we will face error, right? Now we have this try everyone in which we are sending the cancellation token as well. So let me add this cancellation token here. This is what we have to send. In a way, this is just going to try to run our code. We can just print out the result here, right? The result is something which we are going to print out. If in case we get the error, so let me do result is, so that we can see it nicely. Result is, okay. If we get the error, then we are going to catch it. So except, like in Python, that is except, and we can print that error. And finally, we are also going to do something, right? So let me just tell you what exactly will happen here. Now, since we have selected this Docker, we have to run this as well, right? If you will see here, if I go back, we await and run our, or start our Docker command line executor so that the Docker container can be created. But to make sure that even if I face an error, right? To make sure that even if I'm facing an error, I should always and always stop my container, right? So that is the reason I'm going to start it here. So let me just write await code executor agent dot, it was run 1 minute. So what it was, start. Okay. So start, not code executor agent again, docker dot start. And finally, I don't care what happens. I need to stop this thing as well. So that is the best way of running this thing so that we don't face multiple issues. And now since I have defined all this thing, I can just say if name is main, then run this particular thing. And we are all good with our definition. So I will quickly tell you what we have done, everyone. We need a agent which can run this code. And AutoGen provides us a code executor agent. We will be running it inside a Docker container. So I will show you that as well, how that's created. And we initially we are just running our agent as a simple hello world code, right? So let me do one thing now. Let me just run this thing. Let me clear everything from here. And where exactly is this file created? It is outside. So let me do cd back, and I can do Python agent b. Okay, invalid syntax. What we forgot? I think we did forgot a comma here. And yes, and I can run this. Yes, I will have to allow that so that it can mention that Docker. And let us see what exactly it gives. Seems like it has run, everyone. So let me show you the Docker file as well. I think it is on my little different desktop. So see, this is okay. I think it got killed. Let me maybe run it again, and I can show you. See, Python 3 Slim container is created. It is running, and it got the answer. And in some time, it will be stopped as well. So I think that is the reason it quickly vanished. So this again, the best practice, right? Running it and stopping it as soon as our work is done. If like I'll just show you one thing, right? If I don't run it like this, let's say if I normally don't run it like this, print fail. And let's say I make a mistake here, right? So I'm just mistaking it. So, okay, I also forgot to tell you how it is running. See, we can see here that how the content hello world is kind of getting pasted, right? So it will make a lot more sense. Don't worry. Like it is just an output which we are seeing. And ideally, I would like to see this output something like this. So result -1, the last one dot, I think it is messages and then content, right? Although I would not like to trust it. So let us see that what exactly it is using. Yeah, chat message. Okay, maybe you can use that, and we shall be fine here. Result dot chat message. Okay, great. Let me run this again. Let me clear out everything. And have you made an error as of now? Yes, we have made an error. Let me first run it, and then we will see the error part as well. Okay, so it is running. Executor shutdown has been cancelled. Okay, some error happened. It did ran error root unexpected error during stop operation. So again, it has not stopped actually, and which means our agent is still running, right? Sorry, our container is still running. Very bad practice, right? Now I will have to manually go and close it, which and delete it as well. Something which I would not like to do. So that is the reason it failed, everyone. Let me just close this. And now as well, if I made an error, right? So again, since it ran, but I have removed it in a similar manner, if it will be failing any error, sorry, facing any error here, let's say if I just mess up with the code and let me clear everything and let me just try to comment it and say print stopping. Okay, so let's see it now when I run this. So it is saying execute shutdown has been cancelled. We can see the script ran then exited. We will have to a little bit good in this understanding, but yes, as we move forward, we are going to create a good overall UI as well, right? So this is where I ran it. We can see that output was script ran then exited with a POSIX exit code. And what is the exact thing? Stopping Docker executor. It is not able to stop that. That is all fine. So yes, I'm just showing you that how it is not able to run because it is having a problem, right? So if I just maybe try to not access just the result, if I try to access, let me clear everything, run it again. Let's see what will happen now. So again, it is saying that, okay, it was not able to run. The reason is that indentation error. We can see it here, right? So a little difficult to follow, but it is having an indentation error. Now, since we have not handled it like a proper developer, we will have multiple containers running, which I will have to delete myself. Okay. So yeah, let me delete this. Let me delete this. And finally, if I clear everything out, I hope you do understood that how exactly we can define our code executor agent in our Python, right? And let me correct this as well. Great. So now if I go here, in a way, we know that if any code is going to given to our Python, if any code is going to given to our code executor agent, it is going to run this. So very, very important, very a little difficult agent, but yes, we have kind of created that, right? So seems like we are done with this agent. Now, if I can create some logic or some AI or some smart person who is able to give it a code in this manner, we can be sure that okay, it is going to run it, right? So that is the whole logic. That is how things are connecting, right? So now I think we know an agent which is going to help us in that. So let's now see that how exactly we are going to create our that agent which can help us in running this particular thing. Great. So with this code executor agent understood everyone, now let's move on to create this full team. And since we will have to provide a way through which any particular given problem that can be provided with a workable code, I think we need a problem solver here, which is going to give us the logic and the code, and both I believe are very important. So let's do one thing. Let me create a copy of this file so that you have this handy. And I would like to name it enhanced. And here we are going to now add our problem solver, right? So let's go back. And the very first thing which I'm going to do, I am going to just remove this particular task and everything, right? So let me just, for the timing, remove this task and we will see that how we are going to handle it. All the other things are totally fine. So we do have a Docker, which we need. We have a code executor agent. And before the try, we are just starting our Docker, right? Now, I think I need to define a code overall this problem solver agent as well. So problem solver agent. This agent is going to be an assistant agent so that I can use the power of LLMs, right? Which in my case, I guess we are using, okay, we have not defined that as of now. So let me quickly define that as well. So let me do one thing. I think maybe I can copy that from one of the example. And yes, this is what I would like to use. Let me close this. And this is what I would like to use. Now, I think we can just mention, yeah, we can have these things as well. We will be using them. So shall be fine. We are actually going to create a team and all the things which we need for a team, those are present here. So let's now move forward. We are going to use GPT-4o. Problem solver agent is going to be our assistant agent, everyone. A very smart agent, which is going to have a name known as DSA. Okay, one thing. DSA problem solver agent. Now, the reason I'm defining it like this, AutoGen doesn't support spaces in between name. Either we can have it like this as well. And the idea is that I need to see when this agent will be used, right? So yeah, assistant agent have a not. Okay, I think I made a spelling mistake. Shall be fine, right? I can have a description, which is an agent that solve DSA problems. And next, I can have a model client, which is going to be my model client only. This is a very shitty suggestion in terms of what it is trying to do. How can my assistant agent have a team? So don't fall for it. Let us now define a system message, everyone. System message. This system message we have to write in a multi-line. So I would like to have this kind of a comment here. Let us have this and let me make sure that everything is properly wrapped. So what I want to now say to this agent, this will have a lots of effect how it is giving the output. Because for this agent, whatever I'm telling it here in the system message, that is the whole idea, right? So I can just say that, let me write it. You are a overall problem solver agent that is an expert in solving DSA problems. You will be given a DSA problem statement and you will have to provide, no, that is not what I want to do. You will be working with code executor agent to execute code. After that, we have to say you will be given a task. Now I'm doing this right in front of you so that you understand how exactly do we do this prompting and you can avoid any bad prompting which can cause the issue. In case once we run it, once we test it locally, if there are any problem in the prompt, we can surely correct that as well, right? So the whole thing is that yes, you will be given a task and you should, after this, we should say that, yeah, you should write. I'm just providing this in points because I think that is going to be better. Write code to solve the task. Your code shall be only in Python. So this is again very important to mention so that it doesn't start giving you code in Java or some other language, right? So these are small things which you will have to handle. We cannot just assume them, right? So at the beginning of your response, you have to explain, right? So that thing is very important as well, everyone. Or rather, specify your plan to solve the task. So this is very important. Then you should give the code in a code block. So we need the code in a code block, right? So that is why this code thing. I think we can just first make sure that this is what it has to do. And you should make sure that you should give the code in a code block. So this is very important as well. You should write code in a single or one code block. So I don't want that it has multiple code blocks which it is giving out. So that is also something which we explicitly need to mention at a time and then pass it to code executor agent to execute it. So we are saying that, hey, explain your solution, give me the code block. That code block I'm going to pass to the agent executor solution. So the idea is that this overall problem solver, it is going to have a overall response in which first we will have the solution, the explanation of the solution, and then a code block. And we have seen that how code executor agent, it can run the code block, right? So yeah, I think this is fine. We can go to enhanced one. and then pass it to the agent to execute it. Once it does try to execute that, I think it is very important that we see some caveats there as well. So let's see once the code is executed, and if the same has been done successfully, then you have to, so we want that, okay, if in case it does is able to do the code successfully, right? If our agent runs the code successfully, still it should check this out, right? Still it should make sure that it should be checking the code and then saying that, okay, stop, we have done the thing, right? So you have the results because they are going in a round robin manner. First our problem solver, then our code executor. Then let me stop this here. You should explain the code execution result. And after that, we can say in the end, once the code is executed successfully, you have to say stop. So this is going to be our stop is going to be our text mention condition or our stop word, right? To stop the conversation. I think we can check with this much and then we can see if any optimization will be required. So let us have it here, everyone. And seems like it shall work, but we will see if any problem is there, right? After that, I think I need a termination condition. So it is going to be text mention termination, termination condition. And we can just mention that the word which I'm looking for is stop here, right? This is just what you have to mention. Now I can define my team. So team is going to be a round robin team. I'm going to now bind them together inside this particular team. So let me define a team here, round robin group chat, in which again, if you will see, it is giving a very bad error, totally, which has wasted a lot of my time. There is nothing as agents. There is participants, which are your first is your problem solver agent. Here, this order is very, very important. If you mess up this order, then of course your code will get messed up, right? Because first is the problem solver agent, then is the code executor agent. So problem solver agent, code executor agent. Then I can say that termination condition is termination condition. And let me stop it. One thing more which I would like to mention here is this max turns, something which we get in round robin. So to explain you quickly, since in round robin we know that this is how the flow will go, we can specify the max turns, right? That how many turns after which we should stop. So in any case, once they have taken the turns five times, okay, that is what 10 turns me max turns 10 means. It is going to stop. So that is again some better thing which we have here. Now what I can do, everyone, let me okay, so I will have to go here. So we are just starting it. I can actually have it inside this as well. So it's going to be better. And I have to define a task, right? So let us define a task as well. Task is as simple as, let's say, write a Python code to sum or add two numbers, right? This is a simple code which I'm giving it. Now, since this time we have multiple agents which are working, I hope you remember that how we use console.stream. So we are going to use another way here, which I'm going to write. So pay attention here. Let me just remove this. We are going to run in an async manner. So async for message in team.run underscore stream. So my team, it is going to now show me that what exactly is happening. It expects a task. I'm going to give it a task and I can just print for the timing. I can just print whatever message I'm getting. Okay, so this is going to work. And yes, I think rest all things are totally fine. I will just zoom out and show you what we have done. So we have just added this problem solver agent with a termination condition. We have created a team now, as I believe that will be better and able to work it out. And finally, we start the Docker, we stop the Docker container, and we have the messages in a stream which we are going to print out, right? So let us run this now. I hope this works. And if any error will be there, we are going to solve it together. Okay, so Python agent BE enhanced. Okay, 1 minute. Okay, my fault. So we have lots of this enhanced. Let's see. Okay, let's see what will happen. Okay, so seems like something has been printed out. Yeah, this is our message, everyone, if you will see. Then, okay, it is giving us a full plan, defined two variables, everything. Seems like it has defined some code in Python, right? Then DSA problem solver agent. This is our agent only. Okay, so seems like it has stopped it. I think we will have to do a little bit better work in this. Let us try to show the message properly. Let me, first of all, let me make sure that for each message, we just show the source and like this. And we have print so that it is better for all of us to understand that how exactly we are getting these messages, right? Yeah, I think that makes sense. Although message don't have content, so that is something which we will have to check. If I talk about messages, what exactly can we see? I think for the timing, let us run like this, and it will make a lot more sense. So the best thing is that there are no errors, like something which we have kind of handled. So this was our message as a user, everyone. Now I think it is a lot easily understandable. Let me just maybe copy this so I can explain you in a lot of depth, right? Let me, okay, some has no attribute source. That is not a problem. It is going to stop. We know this error. I will tell you what exactly this error is. So shall be fine. Let us try to understand this. Okay. Let me wrap everything. Yeah. See, we first started as a user. I think that's a lot of zoom. We first started as a user and we asked, so this is just the information which you can avoid. We asked that, hey, can you please write a Python code to add two numbers? Now, I use this source here and we could have used content as well, but that shall be fine. Many message type doesn't have a content, right? After that, as expected, the problem went to my problem solver agent, right? So let's go back and okay, we were here. Yeah, it went to our problem solver agent. Coming to our problem solver agent, let me just make it in green because this is someone who will solve the problem. It tried to understand and gave us the answer. Pay attention here. So in the content it has given. So first it is giving us a plan to add two numbers in Python. I will create a simple function that takes two arguments, the number to be added and return their sum. This involves basic arithmetic addition and the result will be obtained by invoking this function. Here is the code to add two numbers. Now it has given us this code. What I can do as well is, let me just help you a lot here. Let me copy this in front of you, right? So let us copy this thing and let us go to, maybe we can go to ChatGPT. Yeah. Can you show this code in a readable manner? Okay. So again, you should be very, very good in reading the logs, but again, I'm making it easy for you. Now seems like this is the code which it has given and it is inside the Python block as well if you pay attention. So that thing it has made sure of this. And let's see the code again. Add two numbers num1 and num2, return num1 plus num2, add two results and it is going to give us the result. So that means when my code executor would have run this code, it should have given this 8 out as an answer, right? Because it just runs the code. We saw that it printed out hello world when we asked it to, right? So let's go back and let's see that as well. Let us make it a yellow color, right? More color branding, everything will be fine. And we can see this. See, the sum of 3 and 5 is 8. That is fabulously well. We have genuinely run the code, right? If there would have been any problem, right? If there use cases, there would have been any problem, it would have given us the error. It would have ran the code, given us the error. Then this particular agent would have solved that as well. So in a way, if you see, it is not just ChatGPT which is giving you a wrong code. It is an incremental full agent system which is properly making sure that it runs the code in a Docker container. And if it faces any problem, it is going to get corrected. Like we can, of course, write that thing. And yes, in the end, it is just going to explain that. Pay attention. So it has fabulously followed our instructions. Now, if I draw it in green again, pay attention. Let me just maybe make it better. Yeah. Let's see this one only. So let's see here the content. The code was successfully executed and it correctly added the two numbers 3 and 5. Result is 8. The add numbers function takes two inputs, which are num1 and num2, and return their sum. In the example usage, it was called with 3 and 5, and the result, which is 8. as printed. Then it is saying stop here. Since it is saying the stop, we made sure that we are going to stop the flow. Else it would have continued, right? Just to show you one more quick thing, let us go back here and let us go to our enhanced agent and say that code in a code block, pass it execute, make make sure that we have at least 3 test cases for the code you write. Okay. Now let me run this again, and I'm very happy that this ran in the first go. I was really hoping that there will be some errors, and let me run this again. Okay, we asked for the code. I just wanted to show you that how exactly it is going to have the test cases now. See, it is going to now have the test cases. I think some error came. We can just follow that as well. I think we messed it up somewhere. The script ran but produced no output to console. The POSIX edit code was 0. So seems like it has just given the code here. So if I just follow this, right? Yeah, I think it has just given us the code and it has messed it up. So see, it has not printed out anything. So hopefully it has stopped and it has given us the code as well. Right. So let us see. Yeah. We can follow this. Should be fine, not that difficult. We shall be like we see one thing more which we see is that how this time it is following the error and correcting them as well, right? So I'm happy that I can show you this as well because understanding this is very important. No chat GPT, nothing can help you there. So where did we ask for this? Code executor agent. Where's the one? Okay. Add two numbers. It. This was the last one, I guess. Num1, num2. Then we ran it from here. Okay. So let me copy this. Let me open another one. Paste it. Remove. I'm going to grab the text. So it's option Z in my laptop. You can see what is it. And yes, we can make a lot of more sense of this. First thing which I would like to show you that why exactly the error came. Directly we can see this code, right? So where it is ending, the code seems to be ending here, right? See, let's execute this code. So let me go to chat GPT and see the code. What exactly is the code here? Okay, so yeah, if you will focus here, seem like it has not printed out anything. And that is what our code executor agent was saying. That add two numbers, it has just called it, right? It is just returning it, no printing, nothing. In the end, it has not printed it out. So that's the problem, right? So it has returned 0. That is what it's saying. The script ran but produced no output to console. The POSIX exit code was 0. If you were expecting output, consider revising the script to ensure content is printing to SD out. And that is coming from my code executor agent, right? Because it's a Docker container, which is very smart and running the code. It is not having any memory. Don't get confused. It is not having any LLM, right? After that, we talk about DSA problem solver. Here now, let's see the code which it has corrected now. So I'm just following these three dots, right? Let us copy this. This time as well, let us see the code. And now seems like it has printed these things out. And it was going to print it something like this, right? Once it print out these cases, and again, the output is exactly the same because my other agent is just a code executor agent which runs things in a Docker container. Like container is dead now because of docker.stop. But yes, it has ran the code. Now the code executed successfully and we obtained the expected result. Adding 1, 2, everything is fine. We can stop. And this error we will correct. That is not a problem. But yes, we have actually stopped. So I hope you understood this, everyone, that how this is now a proper, very good agentic system where it is genuinely a feedback loop kind of a thing, where it is running and understanding where it has made the mistake and correcting that as well. And unless it sees that the result is fine, it is not going to move forward. Rather, keep on correcting the code. Now, if you want, and that is something I would like you to do as a maybe homework, that you can maybe have another agent added here. So we can in the team add another assistant agent, which helps us in making sure that it is telling that, okay, what went wrong? Okay, maybe something, if it is not seeing the output like that, it can tell us. So maybe you can enhance it more. But for the time being, now let's move forward and make it a lot more useful to us. So the very first thing, let us try to fix this error. Like we do saw that there is an error which is coming. Task result object has no attribute source. And I believe that the same can be fixed easily. But before fixing, let us actually also try to understand that what the error is trying to say, right? Now, if I go here, everyone, and see that when we are printing out our message here, that is where it is not able to find the source in one of the message. And it does seems like that message is towards the very end when the whole work has been completed. And it is also kind of trying to give us a hint that task result object has no attribute source. So let us try to further understand the same, everyone. And if I go here and just print out, let's say message, print message dot type before. So I think, yeah, that shall work. I guess message, let us see what all is present in the message. Okay. Yeah, I think we can just print out the message dot type first, or rather it will be better if I print type of message, because message doesn't have that. And we can just understand that, okay, what are the different types of messages which are coming when our agents interact with one another. So to help you visualize the same, if you will see here, our agents are able to interact with one another. And so let me show you. So they are able to interact with one another, but at the end, when the work gets done, they are in a way sending a different kind of a message. So let's see that, and let me run it quickly. So if I do here Python and say agent be enhanced. Okay, not this, enhanced, right? Let's see that. Okay, I think I have Docker has been stopped. Let's just me quickly start my Docker here. So cool, everyone. I have started the Docker, which we can see here. And of course, Docker is a requirement, right? That we have understood already. Now let's go back and let me run this again. So let's start it. Seems like it has started. The type here is text message. So we will try to follow the same. Let us see this. Because I want that we actually understand the error, like fixing it will not be that big of a problem. And finally, the answer is coming out to some task result. Okay, so let me copy this and explain you properly what is happening here. So this is what we are getting. Let me have in title 3 here and pay attention on all of these things. This is, we can make it Lua, that makes it better. Yeah. Pay attention, everyone. So this was again a very simple thing. We just printed out the type of our message and then the message. I can make it wrap and we can see everything. Now, first one was text message, and which is the de facto kind in which our agents can communicate with one another. So they are kind of sending a text message to each other, much like we do. And we can just think that, okay, this is the content or the text which they are sending. Now, this is again the text message. So, yeah, they are still kind of communicating via text messages. After that, if we go forward, we can see that once the work has been done, once it has been stopped, then the type changes to task result, right? Now, to better understand the same, let us maybe go to the official documentation and let me show you that. So, if I go on AutoGen directly, in this, if I go on core, so this kind of comes in core. This is the messages and communication, right? Here we can see that how we can have different kind of messages. So test this agent with a text message and an image message. So if you are building a multi-model use case, then maybe image message is the one which will get sent whenever there is an image, right? Similarly, if I show you here task result, so let us search this. And in the AutoGen agent base, there is a task result type, which is result of running a task. So again, this is very important to understand that how these communication happen between agents inside your team, right? So now we have created a team and communication is happening. So what I will be doing is I will be just making sure that whenever I see this kind of a message, I am handling it in a separate or a better way. So if is instance message is, let's say, in my text message, then I have to make sure that I am, maybe we can, for the timing, we can print the message only with message dot source and this like this way. Else, or rather elif, is instance message task result. Now this task result is something which is not present or we have not imported that. So let's do that. I can just do from AutoGen agent chat dot base. I believe it was present. Import task result. Now please don't fall again for these autocomplete. We have seen that already. So when this is a task result, then of course there will be no source. So I can just say something like stop reason, and I can just mention this. So we have this message dot stop reason. So since now we have specified the type, it is able to give us better overall recommendations or completions. Okay. So yeah, I think this is a pretty nice way of handling, and let us try to run this and I will show you that how this is a lot better to understand and even follow. Let me clear everything out and let us again run this and let's see what will happen now. So I as a user asked to write a Python code to add two numbers. Let me show you the difference here. 1 minute, yeah. So this is where we are starting it. Let me make terminal a little bit bigger. Now, since this starts, write a Python code to add two numbers. DSA problem solver agent first take the plan, right? So here we can see to add two numbers in Python, I will be defining a function. Now, of course, since we have handled this pretty nicely and we are printing out just the content, now we are not printing out these other things in the messages, right? So they are very much required as well, like when the message was created, what was the metadata, all these things are required. You can very well log them or save them into a DB in a production applications, and we can make sure that okay, we have all the information about token, the output token, and that is something which we can surely do. After that, it shows us that okay, what was the Python code. Then code executor agent gave us the answer. Now it is a lot more readable, right? And DSA problem solver agent then saw that okay, the answer is fine, it stopped the same, and stop reason is coming to us that text stop has mentioned. So in the final message, we get the stop reason because that was a task result message. So with this fixed, let's go back and let me close this. And yeah, I guess now this overall code makes a lot more sense with respect to readability as well as handling all these things. Now, let's go back onto our plan and see that what we intended to do. Seems like this is working. Like in our case, we are able to make a problem solver agent. We are able to make a code executor agent or a DSA solver. And overall, this AlgoGenie, whatever we tried to make to solve our DSA problem, it is able to solve the problem. Of course, we are giving it a task or question, and we will see if we can also ask it to generate file. That is not going to be a problem. And finally, one last thing is that now we should move on to the next step and see that how can we structure our code. So as of now, the code is running from a single file, and that is not a lot easy to handle or maintain. Because tomorrow, let's say if you add multiple other agents, or if we are trying to deploy it, or say we are trying to make it much more feature rich, then surely we are going to face a problem. So for that reason, let's go back onto our code and let me tell you what exactly we will be doing. Ideally, I believe that there are some components in my code, right? So the components which I see are components like model. So there is a model which is OpenAI client as of now. Then we have agents. I think we should have agents also in a separate overall folders or files. Then we have team. After that, we have, if we want, termination condition is there, right? Termination condition. Then we can have some constant as well. So all are the basic thing which are present in our code as of now. Let us try to see what structure can be applied to this, right? So let's go to our file. We can see that, okay, this is where the model is. Then we have the Docker again. This is something which we can define in the code executor agent maybe. Then we have the problem solver agent, right? After that, we have the termination condition. Then we create a team. And then finally, we are running it in a proper manner so that we don't face any problem. Okay. So let's go and let me show you one Python notebook which I have created. So let me add this Python notebook into, let me copy this notebook and let me maybe paste it here. Great. So in this, we will kind of try to understand that why there is a structure needed, which I've kind of told you as well. But we can see that, okay, understand why project structure matters in agentic AI. And this is more or less good for any of the framework. So let us try to quickly go through that. That what are the problem which we face in poor structure code? Again, spaghetti code in multi-agent system, difficult finding components, right? You will be searching a lot. It can again be divided into separate files. Then scaling limitation is of course very much issue, and collaboration bottlenecks. Like tomorrow, if I just want to add another agent, or let's say if I want to make some changes, everything will be happening in this file. It can very well happen that it can lead to a lot more issues in general, right? So after that, we can see benefits of good structure, clear component boundaries, intuitive file location, easy updates or maintenance, and simplified testing. So this is where modularity and scalability, again the pillars of a good project, comes into picture. And this is the directory structure which we can follow. Okay. So here we see that how we have the config and settings.py. Then we can have a agents where planner and researcher are kind of present. We will be making them problem solver and code executor. Then we have the teams. So here we will be defining all the teams, making our agent also useful across multiple teams. So this is very good in the sense that if we are creating multi flows where we want code executor agent, we can surely have that in multiple teams. And some utils for logging or state for maintaining all these things, and main.py and requirement.txt. So let us start with that as well, everyone. Then let me create a new folder here, and let us have this as DSA, or let me add AlgoGenie here, right? I guess that shall be helpful. Let me create the very first subfolder in this, which is going to be our config. Then I can add another folder, which is agents. Then we can have team. And I am doing this from scratch so that you understand how we take our full project from a single file into a production kind of a setup, something which I believe many freshers and many people lack. So that is the reason you will understand that how this is getting transformed, right? So let us now see this. And the very first file which I'm going to create in line is going to be settings dot. Let me create it, settings dot py. I guess yeah, this is the one. If I show you one more thing here, like properly, it has explained that what are the file responsibilities, the implementation guide. So you can just go through that, like how exactly do we set up these things. Ideally, I will make sure that all the configuration, everything, I am making it in some constants so that it can be used across my overall project and we don't face any problem in that. So let us do, yeah, this is again, you can just go through this full notebook. It will help you to answer many of your doubts. This is a very well defined, I have created that in with even the testing strategy in mind, something which we will not be doing in this project though. But yes, that is all been taken care of here. Where I have, if you will see production project, we can have the monitoring, Docker file, env sample, everything taken care of, right? So let me close this. Now, let us do one thing further, everyone. In the settings.py, I think we can have import OS. Let me copy the things. For the timing, let's close other parts and also save these ones. So here it will ask us for save. We should do output one. We should save this as well. So it shall be our output two. Okay, it's saving this in config. We will change that. No worries. And let me close this as well. Save. This can be okay. Very big name. No worries. This can be our output three, so that you have an idea that how we saw different output. So let me just make it all in the right format as well. This Lua is a good format to see everything with nice coding. Let us have it. So I don't want them to be part of config. Let us just have it outside our folder, the main folder. Okay. So I have added this. Just to make it a lot easy to read, I will like to create another folder here. And again, that happens whenever we are trying to move things from this way. We can have a project unstructured and all the things which we have created as of now, right? So AlgoGenie we can close. We can have all these files. Let me just have all these files. inside that particular structure. Okay, so this we don't want. Example, team example, everything here we can have inside this folder. We run this in a project construct. Okay, so we are moving them. Close everything, close this. Yeah, I guess now this is a lot easy to understand. This .env and .environment, I can move in AlgoGenie now because that is where the right position of them are. And I guess that is fine. One thing more which I would like to show everyone is that if I go on this agent PE enhance, let me close this. Our Docker also creates. So actually I messed this up. I should be creating this as a TEMP without any of this slash. And if I run this again, let us not maybe read it, or let me have this as a copy. So let me make a copy here and add this here and add it inside the folder. Now again, please don't use my key. That will be anyway deactivated. So let me try to run and show you that how the result will also be saved by the Docker. So Python BE. Okay, I think now it's inside the folder. So project unstructured Python agent BE, and I can just say enhanced. Let us run this. And you see that how this file temp is created, right? So this is created actually by our Docker. And anything which we will be specifying or whenever our code executor will be running, let's say it can generally create files, everything as well. So we can see the same created here inside the temp. Now it has been stopped. Let us see the same. We see that the output is there, right? So this was the code which must have ran. First, I think this code must have ran, so we don't see the output. After that, the second time it was called, this is the code. So we have another level of logging or another level of insight into our project. So let me close this. Now let's go back in the settings.py. I will just quickly close other things as well here. And requirement.txt is fine. Yeah, I think now it's fine. So let us run it like this, right? Load.env. So from .env import load.env, and this chat completion one, OpenAI chat completion, this is where we shall have it, right? Simple approach. We have just defined our model here. But one thing which we have to make sure that now, since this is a separate file, so this file is now created. Let me close everything. And we can just focus on this AlgoGenie here, right? So just focus on this AlgoGenie part. We can use this overall as a environment as of now, should not be a problem. Now, if you pay attention, this is defined here, but I believe that we should be returning it as well. So that is what modularity or adding modules into our code means. So what I will do, I will just define get underscore model client, which is going to return the model client, or rather I should have it inside like this. I should have it inside like this, and I can return the model client. So it is getting defined and the same is getting returned. It is getting the API key and os.get env, etc. Now, ideally, I would want that in the config, I have a new file which is constant. So constant.py. In this, I'm defining few more things, right? So let's say I can define model. Now, just as a way of writing code, we make it in capitals, right? I can say GPT 4o mini. I think, yeah. Or we can just specify GPT 4o. That shall be fine. Then I can have stop, or let's say text underscore mention. It is, let's say, going to be in our case stop. Then we can have the work directory, which can be temporary. Timeout also we can have 120. And yes, I think these are all fine. I hope you get the idea. Like now I will be going in my settings and from config dot constants, I will import my model. And do I need anything else? No, seems like I don't. Now I will be using the model here like this. So this helps me in making sure that if tomorrow I need to change to some other model and I have created multiple such model clients, I can just go directly here and change it instead of changing it in every file and finding it. Now it's a crime in software development world to define this model and not use it here, right? Like even your PR can get rejected if you have done this kind of an error. And I am the kind of engineer who actually rejects like this. So because again, the idea is pretty simple. If I change it here and I don't see the change, like what is the benefit of just maintaining this as well, right? So this is again very, very important to structure your code in a production setting. If you're creating a project, if you're creating an agentic AI project, I think this makes a lot of sense to make it like this. Now, let me define agents. The very first one can be, say, problem solver agent. So, problem solver underscore solver dot py. And I can go on enhanced. Let me first get my agent from here. So, it is going to be problem solver agent. Copy everything. Now, again, it is totally on you how much we want to make it modularized. For example, if we actually want, we can have this particular system message, right, as a system prompt or something outside as well, right? I can define it in a separate variable, or I can have in agents, I can have a system prompt dot txt or dot py, something like this. Py will make sense so that we can use it directly. And this will honestly make better sense. But for the timing, not going into that level because it's a smaller project only. But this all is done so as to make sure that we are able to, in a way, we are able to better handle and maintain our project. That is the whole aim. So if you want to divide it, it's not a bad thing. The more you divide, if it is handling you to make it more scalable, more maintainable, that is totally fine. Okay. So now let us do a few things, everyone. So from AutoGen agent chat dot agents, import not code executor agent, assistant agent. Then seems like I need a model client as well. So from the same is defined in config dot settings get model client. This get model client I need to call. So my model underscore client equals get model client, and I can now use it here, right? Now, since I have this agent also defined, I shall be returning this agent. Okay, so def create or rather get problem solver agent and have everything like this. Pay attention. So define it inside. Let me close this and make it a little smaller. Okay, it is enhanced. But yes, that is the whole idea, everyone. The overall function is now very well defined. I can just return my problem solver agent, and we see that how it is now able to easily get worked up here, right? Like everything is defined here. You can easily handle the same. With this done, I think we should also define our. So this is the problem solver agent. Next is code executor agent dot py. Now I think I can quickly just copy paste. You must have got the idea. So if I go here, code executor agent, we can have the code executor agent. Let me paste it here. Now from AutoGen, okay, my bad, AutoGen agent chat dot agents import code executor agent. Then it does also need, so this Docker thing I will be defining again in, where should I define it? I think I should define it in the configs only, but we will see that. It doesn't need any model client or something, and I can just define def get code executor agent, and yes, it can just work in like that, right? So code executor agent, and we are just returning this code executor agent, everyone. So I hope this makes a lot of sense. We have just divided our code in a similar manner. Coming to this Docker, I don't want to directly make it here. That is the first thing. And second thing which I'm thinking is that, let me just make sense of this quickly. So we just want to make sure that this Docker thing is also properly handled, right? So a better way of handling this, let us try to define this in config. We can define the Docker executor here, because again, this is something which shall be in config, I believe. Now from where exactly it was, let us see the code. Where exactly is it defined? I think this is the one from AutoGen ext. So from AutoGen ext, we are defining our Docker command line executor. That is totally fine. And we can define something like this. Yeah, I think this makes sense, everyone. one thing more, let's define this, or I guess I have defined this in constants as well. Yeah, work directory. So let us go here and let us define this work directory. I hope you're able to see that how this is not difficult, and rather this is helping us a lot in structurizing our code. And the way we are doing it from overall a single code file, I guess that is also very much helpful. So from config.constant, I'm just importing these things. Yeah, I think that makes a lot of sense. We have this Docker executor. Let's go into our agent. Now here from config.docker executor, I can import Docker, or rather get Docker function executor. Now here we can have the Docker present, get Docker executor, use this Docker. But one thing you have to understand, everyone, that we are trying to use this Docker afterwards as well. So if you will see here, we do use this Docker to start, right? So it's fine that we are creating it at a place and then calling it basically to just create it and then adding it to our agent. We will be needing it afterwards as well, right? So we shall also return this as well. So this is a small caveat in this project. We could handle it in a better way as well. So normally what I can do, I can even get rid of it like this, right? I cannot define any executor agent, sorry, any code executor. And afterwards, when I use my agent, I can just define like this. So I can specify this code executor to be Docker. But to not make it difficult for the time being, let us return both of them. And that is also not very big of a problem. So we can just return this Docker as well. So this particular agent is going to give me the full agent and the Docker, which is kind of a configuration, which I shall be using. Now with this overall thing defined, I think we should go to the team. Here we can define a new team, which is our DSA team.py. And here what we generally need to define, so def create DSA team, and let me add it like this. Don't fall for this. Let's rather import our agents. So from agents, now you will see that how nice it is, right? I can just import these two things. Okay. And let me define our team as well. So from AutoGen agent chat dot teams, I have to import the round robin group chat. And yeah, I guess that is thing which we will require. Team is going to be round robin group chat. Participants are going to be this. Now I have to correct this thing. So let us handle that as well, everyone. So first, let's get the problem solver agent. Solver agent. It is going to be get problem solver agent. Then yeah, code executor agent and Docker. This is going to be this. Now I think we can use agents directly. So code executor agent, and we could have, okay, I think this is wrong. We should make problem solver agent first. So small things which we have to handle, which of course will be having a lot of effect. This is how we can define it. Termination condition is none. So for the timing, I can just define termination condition directly here, shall be fine. So from config dot constant import, I think it was, what was the word? Text mention, yeah. So I can now define termination condition. Termination underscore condition can be from AutoGen agent chat dot conditions import text mention termination. And I can just mention it here, text mention terminated, text mention. So tomorrow, if I want to again change this word, I can easily go and change it in the constant. So this is the termination condition I shall be using. Let's go back onto our main file to see if anything is left here. I think this max turn is also something which we can provide. DSA team, and let me provide this max turns. And in an idle developer world, this is something which should also be max underscore turns. So let me go in constant, define the max underscore turns to be 10. And yes, I think now you are able to understand that how am I getting all the constant out. So let's go to a DSA team. Everything seems to be fine. Let me add a comma here. It should also have the max turns coming out. And yes, now I can return the team and Docker, I believe. So it should be create or rather get underscore DSA team and Docker. Now, again, this is not the best way. As I told you, we could have got this and afterwards define the same, but I think we can, for the time being, we can do it like this, right? So return team and Docker, right? So now if you will see everyone, we have defined each and everything here. We don't have to do any problematic thing is not there, which might cause an issue. We have just divided our whole code of one single file into separate files. After this, now what I would like to do further, I would like to now define our main.py. So if I show you this file, project.structure, here we will see that how main.py is present. So let me define this main.py, main.py. And I have to define one more things, right? So pay attention. Docker executor is there. I have to define Docker handler icon or Docker utils. I can just maybe define it like this. Now pay attention. What will we do in this? Async def, and I'm going to say start underscore Docker here. Start Docker container. If I get Docker inside this, I can start the same. So I can just say print starting Docker container, and I can just say await docker dot start. In a similar manner, we can create stop Docker container, and this is also, I think, a lot easy to understand for all of you. But this will help us to do a lot better level of logging and all the things handling in our project. Now, if I go on main.py, I think now all of you understand. In this, I can just do import async IO. Now, I just need to get all the things. So from team.dsa team, I can just get this Docker and stuff. And let me now define. So this is going to be my main function, everyone. I think now we do understand what exactly is happening here. I should also get from config.docker executor import, no, Docker util. Docker util import start Docker container, stop Docker container, right? So let me have it like this. Now I can say my DSA underscore team and Docker. I can get my DSA team and Docker. Now, in a way, what we have done, let me just show you now, everyone. Pay attention. So let me have it here. Okay, 1 minute. So where is the main file? Yeah. Okay, let me see. We can open this. Yeah. So main.py is here. Let me show you the DSA enhanced one, right? Now I know that there are lots of files, but I hope you're able to easily follow. If you are facing issue, totally fine. It took me also a lot of time as an experienced developer to make sense of these things. But believe me, the way I've done it from scratch, it will be very helpful for all of you, right? So please make sure that you see this part again if you're facing some issue. But I'm pretty sure that you will be appreciate once you see that how we are able to easily run it. Now, what I've done, everyone, if you will focus, each and every of these small things I have defined into their own file. Now, Mayank, why is that? Because tomorrow I can reuse them. I can easily add an agent. I can make sure that by minimum changes, I can handle all the things. By defining the constants, I got the problem of overall, say, having any problem in future with respect to values getting used at multiple places out. So this is a very good practice overall, right? Now I need to just run this kind of a full approach. So let us do that. Again, this will be in try thing only. So we are going to first await our start Docker container and pass the Docker here. After that, we shall make sure, again, don't fall for all the things which it says. So after that, we should define a task. Now, if I want, again, I could have the task coming from outside, something which we will see as well. Write a Python code to add to numbers. That is all good. Now I do have the team. So async for message in DSA team.run. If we have the task, then I can just copy it from here. So this is how the things ideally get in a productionized manner. Not nothing out of the world, just some basic handling of part, right? I should import these text message and stop message. Ideally, now, if you would have wanted, you would have done a messages handling differently as well, where we could have imported this, but that would be a overdue for this kind of a project at this time. Let me get the task result as well. Now, since we have defined this, let me copy. Now I'm doing this side by side so you understand that yes, this is just us defining things in a separate location and just using them. So let me remove this and this. So we are in try. Okay, this should be outside and proper thing. Instead of stopping it like this, I shall be calling stop Docker container rather, because it will again print out things as well, right? So I don't have to worry about logging or printing out things once it happens. And yes, this is a simple way of how we have now, in less than 30 minutes, I hope, made our project from not having any structure to having a proper structure. So from a single file, we have defined our project into a proper structure, which all of you can see here. And I hope you can easily just appreciate that how good it is in terms of handling and in terms of running things. Now, if I go on main.py, let me just go here and let us try to run this. I feel like as a habit that there will be some errors, but let's see, maybe it can run properly. Shall we find AlgoGenie? Python main.py. Okay, yeah, there is an error. That makes sense. Cannot import name get problem solver agent. Why is that? Because, okay, this stop Docker container is something which we have not used, I guess. Yeah, that is some mistake. Stop Docker container. So let's now see that good that there are error. It is giving in the main line too. So get DSA team and Docker. This is something which is getting used, right? It is saying that inside this, it is not able to get this gets problem solver agent. So let's see that in the agent, what is the problem? Get problem solver agent. Okay, I think that does make sense. Let me tell what is the problem here, everyone. So in DSA team, agents dot problem solver, this is where you will get this. And from agents dot agents dot what is the other one? Code executor agent. We can import this. Now, here as well, if you want to just have a single import, you can create a file here, which is agents, and you just import all of them separately there and have all the agents imported. Right, let me clear everything out again. Let me run this. Oh, seems like it is working. We have a temp file, that is good. Docker container started, user is saying something. Oh, I'm astonished that it is working on the in this go. And yeah, everything is very nicely being handled, I believe. Stop. Stop isn't text stop mentioned. Stopping Docker container. You can see that how it is so good in doing all these things, right? This is a container which is running. Now, if you want, you could have easily added more logging into your separate files, and that will be carried out over across everywhere. So the reason even I created smaller functions for my this thing as well, stop Docker container and start Docker container as well, is this only. Okay. So very, very important underrated skill which people don't pay attention to. Your code is now a fully modularized code which can genuinely be easily deployed at any location. So if tomorrow anyone is using your code, it just has to start with main.py and it is going to work. Okay. So yeah, with that, I hope everyone you learned a lot of deal in this, because this is something which, as I told, is majorly looked upon, looked kind of that okay, we don't have to do this, or majorly it is something which we don't pay a lot of focus. So if I go on our awesome diagram, I think very nicely we can end right here. Oh, nice. Seems like we have done a lot of part. And generally, at this point, this project is kind of complete, right? If you want, this is a well documented, well structurized, proper AutoGen project. But I would still like to show you that how can we change it into a Streamlit application now, because yeah, that will be more helpful, and we will further see that how can we enhance it more. Okay. So with that, now let's go on to the next part, everyone, where we will try to just change it into a Streamlit app. And further, I showed you that how we will try to get the Python file out from whatever is running. So let's see if our agent can do that as well. Okay. So that will be very good. If the code which is being run, you can also see the Python file there. Right. So let's start with that now. And that is going to be a very good learning opportunity. So great, everyone. Let us now continue, and we can see that as of now, we of course, based on this, have done lots of part. This Python file and this Streamlit is something which is left, which we are doing as an additional part of our project. Now, if I go back and see the initial structure, I guess we have done this project understanding. That is fine. Let us have it in green only. So this is done. After that, code and test AutoGen team, we have of course done that very beautifully. This interactive FE is something which we have to create, and we have maintained a proper end-to-end structure as well, which I hope that should now be a lot clear. So now let's continue and let's go on to our code. The best part that how nicely it is structured. I honestly like this structure a lot. So let's now go to our main.py from which we were able to run this particular code completely from scratch. And let us see that what exactly were we doing here. So the understanding is that given the team and the Docker, I was able to provide a task to my team, run it in a run stream manner, and of course, print out whatever I wanted. And based on all the things which I have done, which I have handled in my agents in my team, I was able to terminate it and pretty well handle each and everything in basically this full workflow. Now, what we will be doing, so ideally, we will be creating a new file here known as app.py in which I will be creating a front end via Streamlit and I will be serving the application which I have created. Right. So first let us see how we can serve the application. Then we will take it up a notch and also try if we can get our file which is getting generated or saved. Right. So for that, let's go once and let me show you. I'm pretty sure that you must be aware about this awesome library Streamlit via which we can create a good front end for our projects. So this is what we are going to use. Now you can easily learn about it, or honestly, if your main aim is of the front end, just you can just let sorry, if the main aim or work is of backend, you can even just use chat gpt or something to write the code, but I'm going to write it from scratch. So let's go and see the same, everyone. The very first thing is in the requirements we should add a streamlit. So let streamlit, because that is some requirement we have to handle. So let's go to terminal. Let me clear everything. Make sure that your environment is activated, right? This is very, very important. Pip install -r requirements. Okay, I think I'm in the wrong folder. Yeah, I'm in the wrong folder. Let me do one thing. So cd, we will be going our AlgoGenie. Let me clear everything now. Pip install -r requirements, and it shall increase. Yeah. So the same has been installed. I think it was cached in my PC. Should be good. Now, before you move forward, please make sure of one thing. Like this is a very common error in Streamlit, which I have faced a lot. Just do which Streamlit, and it shall be coming. So I see that user Mayank Agarwal Agentic AI AutoGen 6 DSA solver ENV AlgoGenie. So AlgoGenie, and it is coming up from the right environment. So this thing is required because when you will be running your Streamlit app, it will be making sure that it has all the overall dependencies and all the libraries which is needed. So now we can do import Streamlit as ST. So this is a very generic way of importing Streamlit, just like we have for NumPy, NP, Pandas, PD. So now let me do st.title. And yeah, I think we can write AlgoGenie, our DSA problem solver. I would also try if we can, like, we can do that. Honestly, we can make it lead code ready. Like if we just tell that it has to provide us with the code, we will be giving this function the way it is in lead code, we will be giving that definition and it can help us with that, right? So after that, yes, we can follow that as well. That is a good overall suggestion. So st.write, welcome to AlgoGenie, your personal DSA problem solver. Here you can find solution to various, not find, here you can ask solutions, okay? And yes, I think this is pretty fine. Let me do one thing. Streamlit run app.py. Yeah, let us see. So it will actually get open on my local host at this particular address. Let me show you how or what exactly are we seeing as of now. So we are seeing this AlgoGenie. It's looking pretty good, right? Our own DSA problem solver. So I think we can just move this R better. And then st.write. Now the idea is that we will be now needing some text boxes, some button, all these things, right? So let's try to add them, everyone. Let me close this. So this has been stopped. It will also show up something. Yeah, so it is trying to connect here. You can see, let me zoom it in a little bit. It is trying to connect here and it will basically see that, okay, application has been stopped. Let us close this. Now, and again, this is independent, though this is a lot common the way it is followed in many of the applications, right? So even if you are using any other framework as well, Streamlit app are pretty easy to make. So that is what you will see many people following. And the major aim, honestly, is to make sure we can create the application which we have created, the backend part, right? Front end wise, it might get integrated into some other pre-made front end as well. So now everyone, let us try to first create a task. So task is going to be st.text input. I think yes. So this is pretty good. We are able to have this text input where we are saying enter your DSA problem or question. Okay, so that is the basic thing which we are doing. Now what we have to do, everyone, we can create a button. So again, what happens? Let me just run this and show you. So I want to show you so that you see that what exactly or how exactly things are happening. If I click this, we can see that now we can enter anything here, right? So that is the whole aim, or that is how we will be moving forward with it. Now let me do one thing. Let me add a button. So if st.button, and I'm providing this run, okay. Then let me just make it cool. So after that st.write, I'm just saying running the task. So this is majorly to show that okay, something is happening. We are going to create it like this. Okay. So once we click that button, that is where this thing is going to start. After that, we need to get our team and the Docker, right? So team and Docker image we need to get. It is going to be very much like how we have this main code. So I can open it side by side. We get this team and the Docker. So let me get this. And I can say from team, yeah, I think this shall work, right? Great. So idea is again the same. I'm going to just make sure that I run this Docker, and from the team we are able to get all the things. Just to okay, so we cannot call this function. I will create another function here. So ideally, we could have also provided inputs here, right? So we could have provided these values instead of directly calling them. But now what I will do is I will be creating another function in which my all the requests will be handled, right? So let us have this, and after this, I can have the first. I can create a task as well. So let me do one thing. We can have async def run DSA, or we can have just run only. That is a good convention of doing this. Team, Docker, and task. So these are the things which I will provide. And inside this, I will be doing await docker.start. So I'm going to start my Docker. Now I think the better way of doing this, we have that function which we shall use. So let me from config.docker utils import start Docker and stop Docker. Right? I think this is something which you should use. Now await start Docker container, and we have the Docker here. And this all again, as I said, we should be having inside a try and catch block. So these things we can follow, or you can do that as well. Shall be fine. After that, we can do async for message in team.run underscore stream, where my task equal task. So this is again totally the same the way we have been coding till now. If I think it is giving us the right approach as well, let us complete it. Now both of these also we will have to import. So from AutoGen underscore agent chat dot messages import text message. So this is something which we can easily do. And from AutoGen base, let us import task result. So that is also pretty fine. Now I should import async IO as well, because it will be requiring this inside a coroutine for sure. Now I hope you're able to easily follow the steps, everyone. We are just trying to create a small function which will help us to run all the things the way we have run in a single file, as well as inside this main function here. If this function I would have provided few things, it could have also worked, but totally fine. I think this is also a good learning for all of us. Just I will like tell you what is the one main thing which we will have to change. And once this is done, once we have everything handled, we can just print out task completed, and we can just do await stop Docker container. So this is something which I should do. Now, instead of writing this message into my Streamlit, right, what I would like to do is I would like to print these messages the way we were doing. And also all this writing, etc., I will like to handle in my once the button is clicked. So that is the whole aim. Instead of doing it like this, where these messages come, I would like to handle them in a separate function so that this is a major function, which then I can move into any other file as well. So that is going to be the whole aim. Now, I hope just make sure that you see the Streamlit video or learn about Streamlit once. That will be very helpful. So we can just do print. And again, I this time if you pay attention, we are not going to print it like everything which is printing. It is going to come inside this, inside our logs, right? Or for our handling. Anything which I want to show on Streamlit, that will be separately handled, right? So let me do one thing, print, and I can just print the way I was doing, but I will do one different thing, which I will explain as well to you. So this is something which I want to print. Everyone pay attention. Similarly, here as well, I want to print message and stop reason. Now, Mayank, what exactly is this message? Why we have defined this? Well, the reason is that since it is a generator, I'm going to yield. I'm going to make sure that I can send this value back as soon as it is coming. So we are yielding it. I hope you know the difference between generator, that as soon as the values are coming, I will be sending them back. That is the reason we are using team.run stream. I could have used team.run as well, but that could have ran everything all together. So 8, 10 messages all together and all of them must be shown. But that is not what we are doing here. We are yielding the message as they come. So if you call a function, asynchronously, any new message comes, it is going to come to you, and we can show that in our Streamlit app the way it should be. Okay. So now let us move forward. We have the team and we have the Docker, everyone. Along with that, we have actually, I guess, the task as well. So task is also with us. This is the task. Let us do one thing. We can now So let us try to now make it complete. I'm going to follow a very easy method of doing this, right? It can be made a lot more complex. We can add many features in our Streamlit app, but I guess that is not the major name here. So now I'm going to do async def, let's say collect messages. So this is how I'm going to run my overall team in this. Okay. So async for message in run. I'm going to call that thing Docker and task. Now you will see that because I've yielded the message, I will be getting the message in this async for message. After this, uh, ideally we could have done one thing, like we could have directly either just do st dot, let's say markdown, right? And then we can just do a message. But I would like to follow a little bit different approach. Now, if you follow it here, we are giving the message source here, right? So let me rather try to do one thing. First, let me show you the basic way, and then we will see what exactly happens. So we can use this for the time being. So if instance message of string, then it's a st.write message, and else it is this. I would just like to make it markdown instead of write, because that would be easier to read. And yes, I think that you will easily appreciate what happens once this has been created. So we have created our function, everyone. I can just run this. So async io dot run my collect messages. So yeah, seems like we have the basic way of at least running it clear. Let me just close and clear everything. So let us do streamlit run app.py. Let us run this and let me show you that what exactly is happening. Let us refresh it here only. That should be fine. Write a code to add two numbers. It will be very nicely visible, and run it. See. So running the task. Let's see what is happening here. Seems like Docker has started. User has sent the message, write a code to add two numbers. I know that it is still not very nicely visible. We will see, we will handle that. My plan to solve this is straightforward. I'll write a function. Now I think you can understand that what is the power of what we have done. So nicely, easily it is able to readable. It is very properly formatted. And after running everything, it is stopping, and we can see the stop reason as well. So all we have to now do, we can just ask it, let's say, write a code to add two numbers. Write a okay, 1 minute. Write a code to sort an array using merge sort. And let me run this. We can see it again. Now it will get started. So Docker container was nicely stopped. Now since it is started, we have the Docker container here. And I hope you're able to understand that how it's just agents coding for you, right? So they will get their error, then they will try to solve it. They will provide you proper code. Execution will happen. Okay, what happened here? Let's see. The script ran but produced no output. So there's a problem, which means our DSA problem solver expert, he is going to correct that particular error. Once that gets properly done, then we can see that, okay, how the same has been executed. And this code now you can easily pick up and maybe submit as well, because you know that, okay, it is working. Now we can make it a lot more better in terms of handling the edge cases. We can make it a lead code problem solver as well. That is not a problem. Yeah, it's a very good DSA thing. Now let me make it a little bit better to overall just understand. So we have already handled this message wala part, that okay, what is happening here if the message is text message or a message is text result. Now let me do one thing. So if message, right, when we are getting the message, or what was it? Yeah, let us handle it here. Now in my message, everyone, I am yielding message.source and message.content, right? So what I can do, if message dot starts with, right, if it's a user, then we can do markdown of 1 minute, and then we can do markdown of message, and we can just put message here. And we have one more thing here. I think it is user. So this will show the message, but what I can do with, yeah, with st dot, if I remember right, it was chat message. So I just wanted to show that, okay, how it's a chat message, and we can do it user, and let me have it like this. So we will see the difference once I will run it. It's these are all just beautification. Now similarly, if message dot starts with, now next message will start with, everyone, the second overall type, like the source. So if I go on team here, where is our team? So this is the team. And if I go on my problem solver agent, the name is DSA problem solver, right? So what I want, if it starts with this DSA problem solver, something like this, then again, I would like to have it in a other way. So yes. And what is the last one? 1 minute. And if it starts with code executor, then we can have a chat.message assistant. So let me just show you this one thing as well. So in st.chat message, we do get icon. I forgot what exactly that was. Yeah, this avatar. My bad. So I forgot this avatar. Anything supported by st.image except list. So what I would like to do, yes, let us use this. Okay. See, this is an avatar which I can use. So avatar, this one. Okay. For a DSA problem solver, we can use an avatar, which is this one, maybe that is totally fine. And here we can use an avatar. Okay. Can we get some other one maybe? So here we can have this, and let us search for something. Yeah, I think this fan. Okay, no, this one is user. So smart or something. No. AI. Okay, we can take or automate. No. Or maths. Okay, no. Okay. Let's maybe use this one for. Let's actually do one thing. Let us use this one here, and we can use this one for our problem solver. Okay. So again, just a little bit of beautification, nothing out of the blue. And I think we can surely do that. st.chat message. What have we missing here? Why is there error? Okay, let me, yeah, okay. I think it is providing something for us. So that shall work. With st.chat message, st.markdown. So they all should be just inside a string, I believe, and then they shall work. Let me provide it. Yeah. So again, this is just how it expects. So avatar is none, default icon will be there. So we can provide a single character emoji, but it should be provided like this. And after that, let me check. We are checking for user, we are checking for DSA problem solver agent and code executor agent. And I think we are printing them as well, so we can very well see what will happen. Okay, so let me now run this. Just one very small change I would like to do here. Pay attention. So in the task part, yeah, enter your DSA problem. How does that? How is it seen to us? Let us see that. Yeah. So I would like to have some default value here. Okay. So it is just asking us this particular thing. We can provide a value here as well, right, everyone? So that is what I'm going to provide. Yeah, value. So write a function, just the default value, so we don't have to write it every time, to add two numbers. And I think we are done. That makes a lot of sense. Let us close this. And now you will like your output a lot. And it is a very good running application. So Streamlit app.py. Let's see that. Okay, my bad. So I think we have started. Okay, 1 minute. Streamlit run app.py. Yeah. Okay, let me refresh it. Yes, that has been killed. Now you see that how this is coming up with a default value. So again, if I want, I can easily change it. But the idea is that at least it is having this default value. I don't have to every time add it. Now let me run it. And let's see how now the output will come. Okay, so seems like Docker container is started. Okay, we have an error here. str start with takes no keyword argument. Okay, what I have done wrong? Starts with it's take a prefix. It's take a prefix. Okay, let us check where is the problem here. Shall not be takes no keyword argument. Starts with return to if starts with a specified prefix, false otherwise. Okay, maybe I can provide start here or something. No, starts with def. It is a prefix by default. Let me check it quickly. So this seems to be right. Where exactly is the problem? Code execute an agent. Okay, everyone. So pay attention. We have done a mistake. Starts with I'm given an avatar here, right? I think it should not be here. Rather, it should be present in the chat message. So let me cut. And that's why it was saying that it doesn't take any keyword argument. Like the overall arguments which it takes are fixed, which are prefix, start or end, right? So no keyword arguments mean you cannot provide anything. That was the reason. Let me close this, stopping it. Although I guess since one very good thing again is that even if we face an error, we shall be stopping. I think our Docker is not getting stopped, right? Yeah. So this is something which we will like to now handle via that only. So if you will pay attention here, when this ran, it was not inside try except block, right? So we should do that. Like, rather, we should do that. So try, and we can have everything inside this. Then we can have except task completed, except exception as E, where we can print this, and else we can have finally. So this shall make a lot of sense. And I think yeah, we should be able to run it. At least one except or final clause that is now there. Yeah. So I guess that this should work, should not be a problem. Just that I don't want that we should have dangling Docker containers which are running without any like if the code will work fine, that is not a problem. But if it in case it fails, that is where the problem happens. Now let me do it again. Streamlit run app.py and let it run. Let us refresh it. Let us run. Okay, seems like yeah. So yeah, now see how good it is, right? We are getting it DSA problem solver agent. Like the idea is that now at least we are getting it in divided, right? So we have done something wrong. That's why we are just seeing it for DSA solver agent. Let's see what is the thing which we have done wrong, everyone. So let us make it a little bit bigger. And okay, so it's user. It is not capital U, so it's user. You can see it here. So this is the one which we need to copy, right? It is user. Then the second one start with DSA problem solver agent. That is fine. and the code executor agent is this. So again, now it shall work properly. Stop reason I think will be there. That is not a problem. We can add a thing here as well. So if that is the case with st.chat message, we can have this as stopper, right? And avatar can be this, and this can be handled now. Great. I believe this shall now run perfectly fine. Let us close this. And you can see that how our Docker container is getting stopped. And thanks to using this function directly, the method which we have created, it is showing you proper logs as well, or at least inside your print statement. Now let me do streamlit run dot app dot py. Okay, let us refresh it. Sure. And let us see. So now it's very proper user. Now we have the DSA problem solver agent, then code executor agent, then DSA problem solver agent, and finally stop. I think here also we have done something wrong. What is the thing we have taken? So stop is coming out as directly. We could have again made it a lot better, but I think that is fine. Like it is at least working properly. And we are also able to see all the things in a proper UI where you have the code as well, which is coming very nicely. Like if I want, I can generally copy this code. So now write a function to sort two numbers using merge sort. So let's see this code as well, everyone. This is a little bit technical or difficult code. Let's see. Okay. Okay, I have to provide print this enter. Sorry, run. So this is we as a user asking. You can see that how nicely it is coming because of just small tweaks. Now DSA problem solver agent. I think it has messed up a little bit of this. Shall be fine. After that, it has given us some code which is not right, honestly. Merge sort two numbers. Okay, totally my bad. I've given the code separately. Merge sort a list using merge sort. So it is merge sorting two numbers, which doesn't make sense. Now this is a bigger question, right? So we can see this. So now it is explaining you as well. To implement a merge sort algorithm, we can follow these steps. It is going to divide. So now this is a proper code, right? And we can see that, okay, this is giving the sorted array. And yeah, it is totally fine. All you now want, okay. So let us do one thing maybe. Yeah, let us be a little bit more adventurous. Let us copy this and say merge sort python solve. Where can we go? It is a tutorial. Okay, can we go here? Yes, I think we can. And can I code it here? No, I cannot. So yeah, majorly I was looking for some place we can code it out so that I can show you that how it will work. Merge sort in Python. No, it is a lecture. Okay, I guess it is in here as well. We cannot code it, right? No, all of these are separate things. So no worries. I think you can easily find it somewhere where you can solve this thing. And I'm pretty sure that this is going to work. If not, maybe we have to just tweak a little bit on the input, what is expected and what is expected as the output. So with that, everyone, we have actually created this as well. So we have a very good interactive front end. We can test our application and do a party. And we have also handled this. Just one very small thing is left, which is your Python file generation. So let us quickly solve that as well. That is going to be a lot easy. So let's solve that. Now, for this, I think what we have to do is we can go to our agents. Now you will understand what is the benefit. See, I can go on my problem solver agent and I can just improve prompting a little bit, right? So that if I handle that, then I'm pretty sure that it's going to work because it is all on the prompting side from which it is maybe causing the issue or it is not able to run, right? It is like not able to run, no. From the prompting side, I could make it save the final file or anything which I want. So that is the major aim, everyone. Let me try to show you that how can we do that. Just give me a minute. So what we can do is this is running. Now you should explain the code. That is good. Once the code and explanation is done, you should ask the code executor agent to save the code in a file. Okay. You should also ask the code executor to run the code in a Docker container. That is all good. I could just provide something like this, and let me see what it is suggesting. No, not like this. So let's say we can have code which is equals to something like, so I'm just giving it that, okay, how exactly it should start that thing, right? Because it is required. It will make a lot of sense once it gets completed. So let me just explain you a little bit here as well. See, if I want to save my code, everyone, what should I do, right? Let's say if I write print hello world here. So a very basic hello world function. Now, there is no way that the code which I'm directly running, I could save it. Like there is no Python function which says that, okay, calculate all the code and save it. No, I should be defining it as a variable. So let's say I could define it as a variable and then we could run it, save it like this. So this is now a code which is inside a string. And now I can maybe create a file by which it can run. Okay, so that is the aim. That is the whole aim. So let's say print hello world. And after that, with yeah, I think this is something which shall work, right? I think we just have to handle this small caveat here. Let us make it double quotes. So 1, 2, 3, removing the extra one, and 1, 2, 3. Okay. So I hope you did understand what I'm saying, that once the code has been checked, once you have explained the code, then send this code something like this, right? So you just follow this thing, that this is a Python block. I am sending the code here, and with open.solution.py as write, I am just writing this code file into my overall this particular Python file. Okay. Then I can say to retry and make sure to provide the code in a block, and we should be good. I guess we can just check it once. Of course, prompting is something which we can make a lot better. But for the timing, just by providing this particular instructions, I could make it a lot better, right? Now, one thing more which I would like to handle, because since now we have lots of to and fro. So if it's a pretty difficult problem, there can be a case where more than 10 messages are coming. So let me go to my config, let me go to constants and make it at least 15, I guess is a good number. And you can see that how nicely my mind is now working. So I don't have to search for max turns. I know if I change it here, everywhere it is changed. So now I will close out few other things. I don't need requirements. I don't need this as well. We cannot save it, shall be fine. Go on app.py. I think this is where our code is running. This should be the case. We can check, okay, like I think it might be created somewhere outside as well. So that thing should not be a problem. Uh, okay, we will have to check that where exactly this file is getting created, right? So where we have created our Docker container in the temp somewhere. So let me do one thing. Let me first delete this folder. Let me delete this folder as well. So the idea is that your Docker is going to use your temp as a working directory, right? So I hope you remember we passed this as well, work directory. So let's see where it is getting used, everyone. So this work directory. I can open this 1 minute. Yeah. So we can see that inside this Docker container, we have this work directory. In the Docker executor, when we do create it, we are providing this temp as our work directory. So let me close this. Now let's go back. Let me close this as well. Okay, let us clear everything. And I really do hope it works. I could have idly checked it directly without the Streamlit, but now I think we have a Streamlit app which is pretty good. So Streamlit run app.py. Let it run. Let's go and refresh it. And let's just add two numbers. Okay. So it is running. We can see it here, starting the Docker container. Seems like it has started. So now I hope that it is very easy to understand. Like this is the code which shall be saved. Now agent has ran the code. Okay, so this confirms add number function is working correctly. Now I will save this code, but I don't think it will be saved. The reason is that our DSA problem solver cannot save this code. It is generating this thing, which is good. it should also be executed by my code executor agent, right? Because that is the agent which is handling everything. Now we see that, okay, this is where our file is getting created. That's a good thing. That is not a problem. Let us change a little bit in the prompt side, okay? So if the code execution fails, no, we should make it a little bit better. You you should send the above code block to code executor agent so that it can run, it can save. I think we can just wrap the text 1 minute. Yeah, so that it can save the code in a file. Make sure to provide the code in a code block. That is all good. And once everything is done, then we can do stop, because stop is our termination word. So let me stop this. And again, this we might have to do a little bit to and fro, but I think we are very good with that, because that is totally something based on the prompt and how well our uh, LLM is able to understand this. But it is giving us the right code at least. So let's now try it again. Function to add two numbers. Okay, seems like that is good. The answer seems to be right. Now it has given the code, and I guess, yeah, now it is good, because we can see that this time it did went to say send this code to the code executor agent. It is not producing like having any output. So for this, honestly, what I can do is I could just add it here as well. So I can just do print. Okay, so this will make sure that since it has a very good context, it will be able to save the file. Where is the file? Yeah, here is the file. Okay, so yeah, I hope all of you are now loving it. This is a very good lead code solver or DSA solver we have created. Let me refresh it and say write a function to write a function to sort an array using selection sort. So let's say someone gave me this question. Let me run this. Now this helps you to enhance 2-3 steps in the pipeline. First, if you just normally use any LLM, it will give you the code. You will have to implement that code. You will have to handle all the things. This time it is doing all these things, right? So it is implementing this. Again, it is, so see, any error as well, it will be able to handle. This time the code ran, but it is not produced any output. So it will correct the code and give you the output. Now, though, since the output is fine, it will try to save this as well. See, code saved successfully in solution.py. And if I see my solution.py, I have the code for the selection sort. Okay. So yes, I guess congrats everyone. Now we have created a very, very awesome project in AutoGen, which is not only giving us the code, it is solving the problem, running multiple iterations, running the code, and if also giving us the solution directly in py file, which you can now just copy paste. Now you're sure that this code is working because it has been tested in a Docker environment. It is not just some code which LLM feels it should work. No, it has been time tested. It has been properly ran. If we want, we could easily give any other, let's say, assistant agent which can further checks or maybe submit it. So all those things now we can handle, right? And of course, if you do prompting and better multi-agent system with user feedback, etc., then what we can also do, everyone, is that we could make this whole thing overall handling the project part as well. So let's say if you have multiple files, just add these files in this tmp directory, because this is the directory of your Docker. It can work on changing those files, or basically it can read from those files as well. So those all things are also possible. Now, if I go on to our AutoGen project, I think very nicely, I could just have a good mark here, right? So yeah, this is also done now. Let me close this and let us see. I guess we have done everything. Our AlgoGenie is nicely working, so we can, no, look at this. This is not good. We could just maybe make a square, right? So everything is pretty much fine. It is working, and we can be very happy that. And I would like to have an image from here as well. So let me just quickly add it, because I found the solution pretty nice. So let's copy this image. We have a full working UI, everything with us. Paste. So see, this is, I think, what we can call a proper end-to-end project. We are following the best practices. We have used Microsoft AutoGen. We have a fully functioning front end. all the result is right in front of us, we can actually see that yes, it will be showing it again because there was no output. It's pretty good in terms of like we can understand that okay, this is a user, this is a person, a agent, or a expert. This is like a code executor robot, and then finally we are able to see that everything is working pretty fine. And yes, it is saying that okay, everything has been done and we are good. Okay. So great, everyone. With that, I really hope that you enjoyed this project. Now, this is not an easy project in any way. It has lots of these steps. I have made sure that all the steps, starting from exact scratch, working on this full code in a single file, we have taken it step by step, first to a end-to-end manner, the way it can be deployed easily as well. Then we have added a fully functional front end, then by just prompting and our understanding, so this way Docker works, that is required to understand that yes, it can save file in this temp directory. We have further added the functionality of adding this python.py file as well, and all of this we have done by having a proper understanding of AutoGen framework in depth. So we did started by understanding the basics, seeing the quick example, and I think this is a very good industry ready kind of a project. You can easily tweak it to your case. Like you can have it, let's say, give you code in some other language, though I guess it might not be able to run it. One very good thing which you can also do is maybe you can make visualization or other stuff from this, because Python do support that, right? So I can maybe have a, like, I'm not going to show you that right now, though I know it will work. I can easily have it create a graph or something for me. Okay. So maybe we can take it as a separate project. But the idea is that this overall thing now is working completely from end to end with the full understanding of AutoGen. So do let me know how do you like the project, and if there is anything else which you would like me to make such end-to-end projects on. Along with that, I hope the understanding of AutoGen is also a lot clear. As I've shown you, neither ChatGPT nor Copilot, these codes are not very updated. So of course, I have to spend a lot of time in understanding each and every component, every function inside AutoGen. If you like the effort, please make sure that you like the video, share this with your friends, share this in your groups everywhere so that people can get uh, in a habit of doing some awesome projects, right? I will be adding more stuff and more projects in AutoGen as well as in other framework as well. So please make sure that again you subscribe to my channel as well. And I'm really sure that in the upcoming days, we will be having lots of learning in the field of AutoGen and other agentic AI frameworks. So thanks a lot, everyone.